in your career for this one. So and also I would like to thanks terima kasih pada tuan trainer kita, Cik Coach. So this first time yang we have a trainer yang volunteered himself to share about his expertise and also want to share lah about the topic that quite interesting in this morning lah. So we would like to thanks Tuan Coach for your time and also for your willingness to share in this platform. So in term of jadi before I go to intro our speaker and our trainer, so let me slide go through just a simple introduction. So just for you guys info yang next we will have another training on 10th of November on how to read PNID, and 24th we're gonna have on the principle of hydraulic calculation, the MPSH regarding on the pump sizing. So this one will be on the November, and we are planning on the next training on the December and afterward in term of this what we have in term of the process control, and also in terms of the guideline to assess the pipe support, and also the risk assessment about the meteorology application from process safety angle. And then we will try to have a guideline in terms of choosing type of control valve, and also this one regarding all the process in terms of the medical. So it's going to be a sharing session by one of the company lah. So in term of ED Engineers Digest, right now just for your info guys, yang kita sekarang tengah in working to have the M-Board punya registration lah. So afterward yang if you guys need it, I guess some of you really need this lah. So it's gonna be beneficial for you guys as well. That's why we are working on that lah. Alright, so I would like to invite to all the participants to on our official website. It's engineers-digest.com. You scan through this QR code. So dalam our official website kita, we will update in term of all the training and all the newsletter yang kita ada. And if you guys tak sempat nak training ke apa, so you guys we have also the training archive. So you can access through our training archive inside the website. And kita juga ada for the training, if you guys to join the next training apa, memang everything is updated in the website lah. And in term of the, if you guys not join our official WhatsApp group, right now we have a 2 WhatsApp group. Participant kita total is about 1,005, somewhere around that number. So it's gonna be a lot of discussion there, a lot of interesting discussion, technical discussion, inquiry, advice. So it's really interesting to you guys to join the WhatsApp group lah. You can get the link from the official website as well. Okay. So I will before I pass pada kita punya coach this morning, kita punya trainer. So let me just quick introduction kita punya trainer lah. So nama trainer kita adalah Cik Kusairi Kamarudin. Tapi Cik Kusairi kita is more comfortable to be called as Cik Kush Kamarudin. Alright. So Cik Kush kita ni actually have the experience is quite huge actually. About 14 years inside the mostly in terms of the oil and gas and also the power sector. And right now Cik Kush is been accountable as the senior inspection engineer. Okay, so that's the basic. I guess afterward, Cik Kush maybe would like to introduce yourself more about yourself. So in terms of this session kita pagi ni, so the first of all in terms of the just talking about how we're gonna conduct this session. So this session will be presented by Cik Kush, and also if you guys have any question, so you are allowed just unmute yourself, tak apa, just unmute yourself and ask the question. So that's the first how you want to ask question. The second thing adalah you can use the chat box, ada chat box bawah tu, you can ask the question there and I will assist you to ask to our trainer lah. Okay, alright. So that's how we conduct the session, and also at the end of session juga kita will still open the Q&A session. So kita punya target in term of time it's about 1.5 hour. So we target to end by pukul 11.10 lah lebih kurang. Okay. Dan kalau
kan?
ya saya
2 hours. Dia bukan 1.5, 2 hours.
2 hours. Okay,
Ya.
my bad, my bad. Okay, so 2 hours sampai 11:40 lah. Okay. Okay, kita punya usual training is 1.5 hours. So this one 2 hours. Thank you for correcting me. So about 2 hours, kalau kita ada terlebih masa, we allow macam dalam 2 jam setengah lah at most. Sebab after that, orang dah start lapar dah semua dah start lapar dah. Okay, so that's how we gonna conduct the session. And boleh saya tahu from the participant yang ada, so in term of the language lah, so is it you guys okay if the trainer conduct in Malay and English, ataupun there are anybody from the participant unable to understand lah, tak boleh, unable to understand Malay, and you guys need to be in English in full lah. So can I have the thing in the chat box, can you reply? So some of them said mix is okay. Okay. Alright. Alright, that's perfect. So far I have a mix is okay. Alright, that's fantastic. Thank you guys. It's really good start for you guys to give some activate the chat box lah. So dah tahu dah macam nak guna kan. So I guess I would like to pass to Cik Kush, but in terms of the language, if you guys ada mungkin miss out or what, anybody yang come afterward ke apa, it's okay, just put your concern inside the chat box, so kita akan sampai lah kepada trainer kita. So I would like to happily invite kita punya trainer, Cik Kush. Please be invite. Salam.
Okay, thank you, Mr. Choi. I kena share screen sekejap. Oh, sorry, infinity window. Right, you guys, can you guys see my screen? Just double check.
Yep, perfect.
Okay. Now I cannot see you guys, so I just have my slides open. But anyway, thanks Engineers Digest, especially J. Shoaib and also J. Syed Idrus lah, for inviting me as the trainer for today. I would say training lah, bukan speaker. So basically we are having this topic, basic corrosion morphology and inspection method detection. So let me just introduce myself for a while. Yeah, my actual name is Kushair Kamarudin, but I go with the name Kuch Kamarudin lah, nama manja kan. So I'm also an MBOT professional technologist and a HRD Corp accredited trader. So I have around 14 years of experience, but mostly in inspection engineering, and inclusive of around 5 years of advanced NET hands-on experience lah. Hence, that's why we have this sharing today. I would say more to like sharing lah, not like education macam classroom. And currently, I'm also certified with several API, C-suite, and also TUV IICS certificates. Basically in pressure equipment inspections certificates, and also corrosion welding and materials certificates lah. Okay, sorry, all the logos down here, I'm not affiliated to the organization for this training. It's just that I'm saying that I am competent to those bodies lah for this moment. Okay, we will have this bilingual session, so we will mix English and Malay. So I hope everyone can be okay with that lah, yeah? Because most of the terms being used in industry is English. So kita nak buat full Malay pun ataupun full bahasa Melayu pun is very difficult lah, I would say. Okay, and this is my life principle. So the best thing a human being can do is to help another human being know more. So again, today I'm not saying that I'm the most expert and terpaling expert kat dalam industri. No, it's just that whatever knowledge and experience I had before, I'm here to share with everyone, and again, just to add another knowledge for everybody lah. Okay. By the way, this training is in collaboration with Engineers Digest lah. Yeah? So I'm very grateful for the Engineers Digest to give me this opportunity. And we have 3 learning objectives for today. First is to understand the basic corrosion morphologies and basic inspection methods. So kita ada 2 topik, which is the corrosion morphology and also inspection method. And then we have some exposure on non-conventional NDT methods, or in other words, we have apa kita panggil advanced NDT. And then the last objective today is to connect those two lah, basically, the corrosion morphology and basic inspection methods. And we want to differentiate which types of NDT methods is being used to inspect our expected corrosion damage lah. Okay, so I hope by the end of the session today we can get all three objectives being met lah. Kalau tak, dia macam no point kita training hari ni kan. Okay, just a brief agenda. There is actually 4 topics, but just very short one. We will start with basic corrosion cell, and then we will continue with common corrosion damage morphology, and then we will continue with inspection examination method techniques, and last but not least is how that techniques can be used to detect corrosion. Okay, and then we will proceed with the Q&A lah. But no worries. Again, as being mentioned by Encik Shuib just now, feel free to open your mic whenever during the session. You can just interrupt me and you can ask your questions. So sometimes if you leave your questions too long, dia jadi macam basi ataupun dah tak ingat nak tanya soalan kan. So feel free just to open your mic. And I really like it if this would be a two-way session lah. It's much more interactive. Okay, some disclaimer guys. This course is designed to give an overview of the basic corrosion morphology. So this is an entry level punya course because it's just 2 hours. So it's not a competent API 571 corrosion materials course lah. And maybe some people think that this course is actually to cover API 571 from A to Z. So actually it is impossible to do it because the whole course, if you go outside, I think it's around 4 or 5 days lah. And API 571 has 67 damage mechanisms. So you don't really have that much opportunity to cover it in 2 hours time. Okay, so we will just touch base a little bit on API 571, touch base a little bit on ASME 5, and we will try to relate the two topics together lah. So that's the objective for today. Are we good? Okay, can I hear some voices from our participants? Kalau ada.
Simple kita jawab through chat box. Yes.
Sorry, I cannot access the chat box right now.
I assist you.
Okay, thank you, Shu.
So, yep, there are multiple. Say all good, sir.
Okay, good.
Ready to go.
Kalau siapa yang tak minum kopi lagi, you can have your coffee. I also have my coffee here. Okay, just a quick question. What happens when you don't really understand your opponent? Anyone wants to try? Anyone wants to give their opinion, insights? Please do so. Ada gambar Muhammad Ali kat depan tu. So what happens when you don't really understand your opponent? This is not talking about industry Kita cakap pasal opponent lah. If you have a fight kan, atau you main game Street Fighter kan. So anyone wants to try? You can open your mic.
So ada yang jawab we will be defeated, ataupun ada yang kata we are underestimate the opponent. Tu sendirilah.
Okay, good question, good answers, which is true lah. And actually you have wasted your energy and lost the fight. And not just you lost the fight, you wasted your energy. Yeah. So again, if you're going for a fight or anything lah dalam hidup kan, kalau you tahu you ada challenges, you tahu you're the threat, you have to understand well on your threats, on your challenges, so that you know the right way to tackle it. So basically today, our concept or the whole package of learning is actually to understand what we are dealing with in the industry, in terms of corrosion lah, for our case. Okay, let's jump to topic number 1. I hope we can try to cover it within the timeline. Sekarang dah pukul 9.50. Okay, let's just start with some background ataupun history. So back in the Roman Empire stage ataupun age, there was a tokoh Roman. We call him Gaius Plinius Secundus, or we call him Pliny the Elder. So dia ni macam seorang pemikir zaman Rom lah, ataupun orang kata orang-orang bijak pandai zaman Roman. And he believed that iron is the best and worst of man's servant. So dia adalah hamba yang terbaik dan terburuk untuk seorang manusia. And buku depan ini is actually his encyclopedia, so-called encyclopedia zaman Rom tu. So everyone was referring to that encyclopedia lah. Okay, and in his encyclopedia, there is a term, you call it ferrum corrumpiter. So ferrum corrumpiter is actually corrosion in Rome zaman Pliny the Elder lah. And what does ferrum corrumpiter means? Corrumpiter means it's actually ferrous and corrupt tau. So it's translated in our latest ataupun recent language is spoiled iron. Iron yang dah rosak, and besi yang dah rosak lah in a way. Okay, and then they believe, and zaman Rom dulu, they believe that corrosion is actually a way to limit the power of steel, and is a form of punishment by God. So in a way, corrosion engineering back then was like a religion. Dia dah macam satu religion. So dia kata corrosion itself is actually a sin of the metal. So that's why God created corrosion, and it's just to limit that iron lah, iron punya capability ataupun strength. Because why? Okay, sorry cerita kenapa iron is best and worst manservant. Iron is being used for making things, useful things like kitchen utensils kan. And it is also being used to make swords, to make arrows. And so dia dah bunuh banyak manusia kan. So that's why that's the sin of a metal lah. And you guys can see belakang ni ada katana. Kalau siapa yang tertanya, yes, it is a katana, but not a true katana. Yeah, it's just a replica lah. Okay, and corrosion is also a form of art for iron lah. That was what they believed back then. Okay, so interesting zaman Rome. But the most important part is why do metal corrode? And this is the most important thing that we have to know. So anyone wants to guess kenapa metal corrode? Okay, kalau tak ada orang jawab, I proceed. So basically, the definition of corrosion in terms of NIST ataupun nama baru dia adalah AMPP. So the corrosion is actually a deterioration of a material, usually a metal, that result from chemical or electrochemical reaction with its environment. Ni dalam bahasa textbook. So in the words of textbooks, this is what corrosion has been defined. But in bahasa kasar dia ialah, it's just a chemical and electrochemical reaction. It's a natural reaction which reacts of the bare metal and the environment reacts. Environment ni not just your atmosphere, but whatever liquid or whatever fluid that you contact, that is in contact with the metal, is actually called environment. So let's go to that later on. Okay, so this is the cycle of why metal corrode is actually. So basically, our metal products was originated from metal ore. Metal ore ni adalah kita panggil apa dalam bahasa Melayu logam semula jadi raw metal lah yang kita ambil daripada tanah. And these metal ores are actually in a stable state. Cuma dia tak cantik, dia dah berkarat. And karat itself is actually the natural form of metal.
Tuan, ada yang kata ore tu adalah biji.
Oh, okay, biji
ada yang bagi tahu.
Macam rumah lah kan? Okay, betul. Sorry bahasa Melayu kadang-kadang kita susah nak translate. So biji besi, biji besi, thanks. So when we want to manufacture a product, let's say my sword belakang tu, so we have to add some energy. We have to do orang kata apa? We have to buat heat treatment, kita kena buat quenching and tempering. So barulah dia jadi satu manufactured metal. And kita kena buat machining. So by doing that, we are actually adding energy into the metal. And sebab kalau produk besi tu, and if the metal is being sold at a original form, I think no one wants to buy it because it's not shiny kan. Kita kan suka barang-barang yang berkilat, shining. Dan cuba you bayangkan you punya iPhone tu berkarat. I don't think people will buy it lah. I mean unless zaman Rome dulu lah kot. Sebab they assume those are art kan. So kita nak barang-barang shiny. So we have to put some energy lah and into the manufactured metal. But then if you leave it at the atmosphere, so it will try to go back to the original state, and that original state is actually the corroded punya form of the metal lah. And the corrosion product is actually the byproduct lah from the metal itself wanting to go back to the original state. Okay, so saya dah bagi contoh tadi seperti apa pedang di belakang saya. So basically itulah barang-barang whatever metal products that you are buying. Metal product kena declare sikit lah. Katalah barang-barang carbon steel kan. But actually barang-barang stainless steel ke, barang-barang copper, barang-barang zinc pun actually they are in definition they are experiencing corrosion. It's just that the corrosion that they experience is a positive corrosion. Untuk kita, the normal carbon steel karat is a negative corrosion, so-called negative lah. Okay?
Tuan Coach, ada soalan pada Cik Ifan. Apa beza corrosion dengan rust tu?
Corrosion dengan rust. Okay, corrosion is the process, rust is the product. Menjawab soalan?
Coach.
Rust tu yang kita punya tak silap saya dalam chemical punya nama tu is ferrous hydroxide. So that is rust lah, rust kita punya karat kan. Scale tu, rust scales.
Cik Zarik ada jawab kat chatbox ni sebiji macam Tuan Coach jawab. So betul lah.
Thank you. Siapa-siapa yang boleh provide some answers is good. You guys feel free to chip in, to give some ideas ke ataupun opinion. I don't mind. Okay, so what makes a corrosion cell? Bila kita cakap pasal corrosion, there must be elements ataupun elements to complete that cell lah. So actually you have to have four things lah. You have to have four elements, which are the anode, the cathode, and then you have a metallic path between the anode and cathode, connecting both anode and cathode, and then it must be exposed to the electrolyte lah ataupun environment. So this is if you guys from science stream masa back in your high schools, you must have learned this, but biasalah bila kita tua-tua kita tak ingat sangat pun. So this is just a revision. So we have to have all these four elements in terms of creating the corrosion cell. So selagi mana we don't have all these four elements, if you close one ataupun if you eliminate one, let's say we eliminate the electrolyte ataupun we eliminate the metallic path, so corrosion cell will not be completed and corrosion will not happen. Okay, so that menjawab macam mana kita nak control ataupun kita nak eliminate corrosion sebenarnya.
Alright, Cik Coach.
Yep.
Ada soalan daripada Cik Nazmi. So sekarang ni Cik Coach talking about corrosion. So tapi dalam API is just talking about damage mechanism. Is it the same thing?
Okay, we'll go through that later. Boleh?
Alright.
Boleh Cik Nazmi? Put hold your question. Nanti kita akan go through kejap lagi in topic 2. Okay. Bagus. Right. Thank you for the questions. Okay, so when you have a metallic path, you have the electrons flowing from anode to cathode, and then you have ions being transferred from anode to cathode and cathode to anode lah. So again, if you read back the definition of corrosion, it's an electrochemical process. So we have here electrochemical process lah. The electric part is actually the current between anode and cathode. Those are the electric currents. And then we have the chemical part going on the transfers of ions from the anode to the cathode from the electrolyte punya medium lah. So if let's say you don't have the medium, there's no place where the ions can be transferred together lah. Okay, and always the cathode is being protected by the anode. Kalau korang ada masalah untuk ingat what part is being protected, because to be honest, sampai sekarang pun I get confused. Anode ke cathode yang being protected. So I selalu ingat cathodic protection and CP kan, orang selalu sebut CP. So CP, we are trying to protect the cathode, atau we are trying to create the cathode. So that is actually CP lah. CP punya apa orang kata konsep. But CP, we will not cover CP here. CP is a very it's actually an interesting topic, but it's a very complicated or complex topic to be covered, and is a one topic of its own. Okay, and then basic corrosion cell, we have three so-called types of corrosion cells. One is the concentration cell, two is bimetallic cells, and third one is thermogalvanic cells. So concentration cell is actually the anode and cathode is from the same material. If let's say you have this is your besi, so your anode and your cathode is actually on the same material. And so one part is anode, one part is cathode, so they will be transferring ions and electrons. So that's why kalau you perasan, kalau you ada sebatang ataupun satu besi lah, you ada satu bongkah besi, and if let's say you letak dekat environment, you akan nampak dia berkarat. Walau it's the same thing, anode and cathode is on the same thing lah. Okay, and how it happens, sometimes it happens because you have some anodic side and cathodic sides dekat metal tu sendiri. So that's why you have that transfers of ion and electrons. Okay, and then you have the second one is bimetallic cells. If let's say you have, let me just quickly take this. Katalah you ada satu, I don't know, this is titanium, and then you have besi. So if let's say you put contact together, then you have two different metals, and one will be anode, one will be cathode. So that is where your transfers of ion and electrons will be happening. And then the third one is thermogalvanic cells. This is actually the same anode cathode metal, but with different temperature on each sides ataupun each sites place. So basically maybe due to heat treatment ataupun due to the conditions of two different temperatures, so it can gives you it can create its corrosion cell itself. Okay, just some visualization of what we learned just now. We have anodic area, and then we have a cathodic area. So from the anodic area, it will transfer ions to the cathodic area, and the electron path pun akan ke sini lah. So in a way, they will donate their electrons to the cathode. So the anode will sacrifice itself and donate the electrons to the cathode. And this menjawab soalan siapa tadi? Irfan je yang tanya rust ataupun corrosion tu apa beza je kan. So corrosion is actually the whole process. Rust is ferrous hydroxide ni lah, Fe2O3 times H2O. So this is ferrous hydroxide. Okay, we won't go through all the chemical reaction punya equation. I think just understand the concept and the basics. That's much more important. Alright, so kalau you selalu dengar orang cakap the structure is badly corroded. So how bad is bad? Kan? Pernah tertanya soalan tak? How bad is badly corroded? Pernah tak? Okay, so normally if okay, the term badly corroded is very subjective because sometimes when you have a subjective term, it also depends on the person who's asking it or the person who's defining it in terms of their capacity of knowledge and also experience. Kan? Kalau tengok the picture on your left and the picture on your right, maybe somebody new to the industry, maybe somebody new to the topic, they will say that this is already badly corroded. But
Cik Kush, ada yang kata, ada yang menjawab mungkin badly corroded tu bila adanya leaking. Contohnya.
Okay, bila ada leaking baru bad lah. Okay, I like that. Sebab orang plant mesti suka tu. Lagi tak leak, okay. Okay, tak apa, we will touch that just the slide after this.
Alright, and also Cik Kush, if I may interrupt you, so macam on the previous slide, so Cik Kumar tanya, so like in a battery dalam remote control TV, so dia akan berkarat sendiri. So is it some I guess this question talking about yang pasal single atau double tadi bimetallic kan? So
Okay.
is it Is it something like that juga lah
I think it's not about bimetallic. Okay, maybe it is about bimetallic as well, but I think because of there are presence of electrolyte dah. Kan? Sebenarnya you punya bateri ni you janganlah letak dekat dengan air kan, sebab dia akan berkarat kan. Okay, I have an experience. Sometimes you ada shaver kan. Biasalah kita kadang-kadang malas. You bateri habis tapi you tak buang, you letak kat dalam maybe you punya compartment cermin ke apa, you letak your bateri kat dalam tu kan. So you perasan tak sometimes bateri tu akan berkarat sendiri because of actually the environment, because dalam bilik air kan humidity kita tinggi. So we have the presence of the electrolyte there. So electrolyte in this case is water lah. And so that's why you can see that there are corrosion happening in that area. But in terms of the process itself tu, I'm not really sure how the corrosion berlaku kat dalam remote control TV you tu. But if you perasan, maybe you simpan tempat yang agak sejuk kan, you letak dalam aircon, so lama-lama dia akan berkarat. And lama-lama berkarat ni sebenarnya your battery is too long in there. Kalau you selalu pakai sebenarnya tak akan berkarat pun. You kerap tukar bateri kan. So if that helps lah on the question.
Alright.
Okay, so,
Alright.
Thanks for the question by the way guys. Okay, so again let's go back to this picture. So maybe orang yang berpengalaman and berpengetahuan, they will only say it's badly corroded on the right side. But who's right? And siapa yang betul? Mari kita tengok siapa yang betul. So how we want to define bad is actually in terms of corrosion rate lah. Kan? Sebab we are in the engineering world and we don't define things in a subjective manner. So that's why in API, just some sharing in API, let's say 510, 570 or 653, there is a term, we call it corrosion rate. So what is corrosion rate? It's actually the rate of metal loss due to erosion or erosion corrosion or any chemical reactions with the environment, either internal and or external. So both internal or external. So how bad is actually you have to look back on the corrosion rate. So how you want to calculate the corrosion rate? You kena kira lah. You have to know the thickness of that material. Let's say in 2024 versus 2021 or 2024 versus 2018. And so that is what we call long-term and short-term corrosion rate. We won't touch much on this one because it's a very API 510, 570, 653 punya topic. But just want to tell you guys that if you want to say something is badly corroded, get some numbers lah. Because we are in the engineering world, we don't make decisions by we won't, but we try to avoid assumptions. But sometimes we have, but not too much. So when you say badly corroded tu, sometimes dia tak menggambarkan the real condition. But if let's say you put it in a different statement, the wall loss, the pressure vessel has experienced 80% wall loss. 80% wall loss. So in a way, you ada lagi 20% sahaja wall remaining kan. So again, that is how we try to put things in context when you talk about corrosion. And then we always go back to calculating the remaining life of an equipment. So from the corrosion rate, you can actually calculate the remaining life of a certain pressurized equipment. Okay, let's go to the next question. Can we stop corrosion? Kita boleh hentikan pengaratan atau tidak? Okay.
Jadi Tuan Coach ada bertanya, Cik Zari tanya, is there any method untuk kita monitor corrosion rate other than monitor the thickness tu sendiri? Dan apa bezanya oxidation dengan corrosion?
Apa beza oxidation dengan
corrosion?
Oxidation dengan corrosion. Okay. Yang soalan pertama tu we will touch later on because that is the whole point of this module. Okay, tapi I try to answer the second question, the second part dululah. So oxidation is okay, dalam corrosion sorry, tadi oxidation versus apa? Corrosion
Ya, betul.
Okay, dalam corrosion, actually kita ada half cell tadi kan. Okay. Kita ada half cell. This is reduction, this is oxidation. Ke saya balik? Sekejap. I think I terbalik. Oxidation is giving, reduction is receiving. Betul. So kat sini dia mengalami oxidation process ataupun oxidation, we call it process lah as of now. So dia akan mengalami oxidation, and this is where dia mengalami reduction. So it's actually, oxidation is a terminology of the half cell process of corrosion. So benda tu berkait, but oxidation is a subset of corrosion lah. So actually, kalau you berminat further, you can look for oxidation and reduction of process. So they will tell you all the chemical equation from here to there kan.
Dan kalau ada juga another tambahan question daripada Cik Farhan. So Cik Farhan tanyalah, dalam steel corrosion, dia punya anode and cathode area tu exist, but how does the entire steel corrode if this area are localized, or ataupun this anode and cathode ni dia shifting over the time inside one metal tu?
Okay, can we cover that in topic 2? Sebab
Alright.
ada kita pasal uniform corrosion and localized corrosion. That is where you will get the answer. Is it okay?
Alright, for sure.
Alright. Okay, so back to the question. Can we stop corrosion?
Ada yang menjawab, we cannot stop, but we can control maybe.
Alamak, pandai lah. Mesti orang yang jawab tu dah ambil kelas lah. Yes, actually yes, we cannot stop corrosion. It's a natural phenomenon. And dia adalah fenomena semula jadi. So we cannot stop it. It will happen no matter what. But we can only manage it. Ataupun we can only control atau mitigate it lah. So that is where we have corrosion management. So in corrosion management, we have corrosion control, we have corrosion mitigation, and we have also corrosion detection. And today's topic is mostly being focused on the third part lah, on the corrosion detection. Because corrosion control, you cover it on the design stage, in the design stage. Corrosion mitigation is, you know that the corrosion will happen, so how you want to mitigate it, how you want to mitigate it. And you nak pasang CP, and you want to pasang corrosion probe. Sorry, corrosion probe tu sebenarnya in detection. You want to pasang chemical inhibitors. So those are at the corrosion mitigation part. But we will cover on the corrosion detection. You know that the corrosion is there, and you already put some mitigation, but you just want to detect whether the corrosion is still there or not. Ataupun you want to measure the corrosion rate. So that's why that is the topic for today. Okay, I think we are done with topic number 1. More or less 20 minutes lah tadi kita cover. Okay, tak apa. Any questions, you can just put it on the chat box. Nanti Encik Shuaib akan pick up and ask. So let's just proceed with topic number 2. Tadi ada beberapa soalan from the topic number 2. So we will go there. Jangan risau.
Mungkin ada question, tapi saya rasa maybe we will cover by other topic. Tapi let me highlight it first lah, Tuan. So
Boleh.
yang pertama, ada yang bertanya in term of the how about the monitoring of piping fouling corrosion. So that's the first question.
Pipingnya apa? Apa corrosion?
Piping fouling corrosion.
Fouling, F-O-U-L-I-N-G.
Ya, betul.
Okay. Alright.
So that's the question. And second question adalah regarding on the how can we stop corrosion by using CP.
Okay. The second question tu kita takkan cover in our module, but just let me quickly answer that one. The first question tu we will cover later on. How we stop corrosion using CP is actually back to the fundamental of corrosion cell tadi. So you have anode, cathode, kan? So in CP you are trying to make your equipment as a cathode. So that's why you call it cathodic protection. So if let's say I want to protect this equipment being buried underground ataupun buried dalam laut, ataupun let's say mana ada pipe tak? Tak ada pipe. Sorry, I tak ada pipe. Kalau ada pipe, if you have I think I ada pipe. Not an actual pipe lah, tapi pen. So if let's say you punya pipe ni duduk dalam laut atau duduk dalam tanah, so this is actually being exposed to corrosion. So how you want to protect it? You try to force ataupun you sebenarnya manipulate tau. Catalytic protection is actually manipulating the fundamental of that basic corrosion cell. So you are trying to make this as your cathode. So you impress current, you masukkan current punya apa semua kan. So that's why you ada satu anode, you akan paksa anode tu sacrifice untuk protect this structure. Let's say I want to protect the purple color, so I ada satu lagi anode, I introduce an anode here. Kita sengaja sacrifice kan anode ni untuk protect the cathode. Faham? Tapi you jangan apply benda tu dekat persahabatan you jangan sacrifice kawan you. Basically macam tu lah. You ada orang yang maybe lemah, so you kena kejar dengan harimau kan. So you saja tinggalkan orang lemah tu kat belakang lah. So at least harimau tu dah makan. Sorry lah, jokes aside. But that is actually the way CP works lah. You manipulate the corrosion cell.
Alright. And also this one last part of the question yang I guess we cover later, tapi let me emphasize yang daripada Cik Amiro tanya, Cik Amiro is inside the food industry and the temperature is quite rough, about 4 to 7 degree. So dia nak kata kalau everything you change to stainless steel is gonna cost a lot. So and some of the bolt and nut tu they keep rusty lah, yang bukan stainless steel. But kalau dia want to apply painting, dia takut contaminate the food. So is there any method or they can do lah on this issue?
Interesting. Sorry, first of all, Encik Amirul, I'm not from the food industry. I know that food industries are much more stringent. I'm not sure on the requirements in terms of technical requirements of your codes and standards, but I think they do require stainless steel, right? Because not just because of pengaratan, but because of the hygiene. If you look at ASME BT 1.3 piping pun, dia ada satu kategori I forgot what you call it lah. Tapi dia untuk the hygienic punya processes macam pharmaceuticals, food industries. So I'm not sure whether there is any other ways to avoid from using stainless steel. I mean, in my limited knowledge. But thank you for asking that. If let's say I have some idea later, I will try to share lah. Boleh?
Alright, sure tuan.
Okay. Alright guys, can we proceed for the next topic?
Yep, sure. Nanti kalau ada question tu, I will chip in afterward lah. Cik Coach.
Alright, sure. No worries, just chip in. Okay, topic number 2 is about damage mechanism and morphology. I think Irfan ke siapa tanya tadi pasal damage mechanism. So dalam code, yes, we call it damage mechanism, but this terminology damage mechanism is actually from API 580, 88580 risk-based inspection. So the definition of damage mechanism, is any type of deterioration encountered that can result in flaws, defects, and that can affect the integrity of the equipment. So example given is corrosion, cracking, erosion, dents, and other mechanical, physical, or chemical parts. Okay, here you have to understand that damage mechanism is not just corrosion. You can also treat it as something yang boleh memberikan impact ataupun failure towards your equipment. So menjawab soalan tadi, damage mechanism is much bigger than corrosion. Corrosion is actually a subset of the damage mechanism. Because when you open API 571, there are actually 2 damage mechanisms that are not corrosion sebenarnya. And while I was taking my examinations back then, API 571, I tried to categorize all these corrosions. Tapi somehow ada dua ni sesat tau. Macam it's not even corrosion pun. Dia cakap pasal gaseous oxygen combustion. And so that is not corrosion based punya damage, but it is also being mentioned in API 571 because again, damage mechanism is not just corrosion, but it is actually the deterioration or flaws, defects that can affect your equipment. And in API 580 juga dia cakap deterioration is the reduction in ability of a component to provide its intended purpose. So if let's say you have a vessel, you want the vessel to contain a pressure, tapi dia tak boleh. So whatever yang mengakibatkan dia tak boleh nak contain the pressure is actually damage mechanism. Okay. And the terminology of damage, degradation, and deterioration is actually interchangeable lah. Okay, so we have damage mechanism, credible or potential. We can use potential. And then we have the term damage mode. And then we also have the term failure mode. So these are in API 580, risk-based inspection. So what are the terms means sebenarnya? So damage mechanism is identify the type of damage, yang macam saya cerita tadi, and typically we will refer to API 571. But if you open ASME PCC3, they also mention several reference, several credible reference, such as NACE and others, in terms of what damage mechanism that they portray lah. But in oil and gas, normally we will focus on API 571 and NACE sebenarnya. Kita ada NACE juga. And then damage mode is actually how the basic morphology being caused by that damage mechanism. And adakah dia local corrosion ataupun adakah dia general corrosion, or is it actually giving you a crack-like defect? So those are damage mode, and that is what we are going to cover in this topic sebenarnya. And then we have failure mode. So failure mode is much more important for RBI to determine the consequence of failure, COF. So COF and POF is actually an RBI punya terminology. So failure mode is actually more affecting to your COF analysis. Damage mechanism is affecting to your POF analysis. Sorry, this is this is going to be complex kalau kita masuk dalam risk-based inspection. Is a very different ataupun separate punya topik. I'm just giving you a sneak peek of what damage mechanism is all about in API 580 and also in the industry. Because normally, when you guys operate, we will have some sort of reference or some sort of methodologies that we are applying through to our operation and maintenance. So damage mechanism is mostly being used for oil and gas, and I believe also for the industries as well, not just oil and gas. So RBI pun banyak orang pakai, so this is also related to our topic lah sebenarnya. Okay, let's say we have the damage mechanism macam kita tengok tadi, dia kena identify the internal and also external damage mechanism. So let's say I have a pressure vessel here, ataupun this is my tumbler yang ada kopi kat dalam. I'm not sure you guys boleh nampak ke tak, tapi ada kopi kat dalam ni. So internally I have a product. So what is the product? Espresso lah. But espresso, I'm not sure whether it's going to be corrosive or not. Kan? Nanti marah kawan kita yang from food industry kan. But it is a consumer's product lah. But my material is stainless steel. So you have to identify what damage mechanism from the product, which is internal damage mechanism. And let's say I'm exposing my pressure vessel, so-called pressure vessel, outside. Tak kisahlah dekat whatever environment. Kalau I letak dalam air, then my external corrosion ataupun external damage mechanism will be subjected to whatever product being surrounded externally. But internally, I have the product, and internally I have coffee lah. So if let's say we have this pressure vessel and piping on site, so we can see here there's an insulation here. I tried my best to illustrate. I hope you guys understand. And then we have piping outside here going to the soil. So coming into the soil. Sorry, I lupa nak letak support. So minta maaf. Mungkin siapa piping engineers kat sini nampak tak logik kan, tak ada support. So this is the condition. So let's identify some internal and external damage mechanism. So let's say this is the vessel wall yang besi. So internally dia ada produk dia, maybe coffee. ataupun in your plant, maybe let's say you ada apa, H2S, you ada chemicals, and then outside you have atmosphere. So your external damage mechanism might be atmospheric corrosion sebab dia duduk kat luar je. But then internally it depends on your product lah. Kalau you ada ammonia, maybe akan ada ammonia stress corrosion cracking. And kalau ada caustic, maybe akan ada caustic corrosion. And okay, so understand on how we determine internal and external. So internal is actually internal of the pressure equipment. Okay, the next one is on the soil. This is a different case ataupun different scenario where your external, walaupun it's external, it is in contact with soil. So maybe you will be experiencing soil corrosion kalau you tanam your pressure vessel ataupun you punya piping kat dalam tanah. Even though it is coated, it is still susceptible to soil corrosion. Okay, and then you have the product inside. Again, product. And then this is the interesting part. Whenever you have insulation and your metal ataupun your material is being exposed to the material and temperature range of each material, so you might have CUI. So insulation, in your case, insulation is the external condition, not atmosphere. Walaupun you letak dekat tanah dekat tempat yang kering, tapi you tahu tempat tu ada hujan, and water can seep into your insulation. Maybe your insulation conditions are not very good, kan dah operate 30 tahun, 40 tahun, so ada pecah-pecah insulation, so ada air masuk. So those water ingression and water retention is actually being the corrosive environment for that particular pipe wall. Okay, so from here you have to register your external damage mechanism as a CUI. CUI is your external damage mechanism. Okay, I hope understand is good. I hope everyone is good. You guys can understand this one.
Dalam chat box pun cakap yes sir, we understand.
Good.
Mantap. And also sebenarnya tuan, tadi in term of the CP tu, actually we have multiple additional question. Do you mind to attend this one, tuan?
Okay. Depends. Ataupun sorry, kalau CP tu boleh kita try to cover kat Q&A tak? Sebab CP is not the main intention here, because again, CP is a very complex topic, and saya pun sebenarnya bukan competent CP punya person lah. It's just that I pernah pergi kelas CP. More or less kalau I boleh jawab, I can try to answer lah. But can we touch that on QA session nanti?
For sure tuan, for sure.
Okay guys, sorry kita sebab kita ada some topics to cover. Okay, so let's go back. So these are the reference yang kita normally pakai tadi, API 571. I still use the previous code ataupun previous RP, recommended practice, sebab nanti I cerita kenapa. So the latest one is actually March 2020, the version March 2020, third edition, and we have the second edition. It is still relevant because why? Back then in 2011, API 571, they tried to categorize all the damage mechanism into some groups of categories. So nanti kita akan tengok kejap lagi, I ada buat some hierarchy. But in 2020, they revised the whole document to be alphabetical order. So kalau you nak cari atmospheric corrosion, you kena buka huruf A lah. Kalau you nak cari wet H2S damage, so that one is the last damage mechanism. So dia nombor 67. So the first damage mechanism is 885 degrees Fahrenheit embrittlement. So dia dah susun ikut alphabetical order. For somebody who is already experienced in the industry, experienced in using or referencing damage mechanisms in API 571, 2020 version is much better atau much useful for them because they know what they want to look for. But in terms of education ataupun knowledge, kalau you baru nak start, you want to open up API 571, I really recommend you guys to to find the April 2011 version, because that is a much more makes sense way to learn about damage mechanism sebenarnya. Okay, and then tak apa, kita akan cerita a little bit after this. But how they structure API 571 is actually like this. They start with the name of damage mechanism, let's say soil corrosion, and then they will give you a description damage, a little brief damage description. They will tell you what affected materials. Kalau katalah they affect only carbon steel, so maybe they will put it here 300 SS and 400 SS steels are highly I forgot the word, tapi in a way tak applicable to this damage mechanism. Highly resistant, yeah, that's the word. It is highly resistant to the damage, katalah macam tu lah kan. And then you have critical factors in terms of whatever list of factors. It can be operating parameters, temperature, material. They can also put it here. So these are the critical factors. So this is why, and so the why benda terjadi. And then there are affected units, equipment, the common ones lah in refineries. Again, you have to remember API codes are berkisarkan tentang oil and gas and petrochemical, and so you cannot run from there. So that's why they will focus on giving you some guides for the affected units for refinery. So here you can see where it can happen, and then appearance, morphology of damage, how it looks like, prevention, mitigation, how to detect, how to mitigate. Dia akan cerita kat dalam ni. This is prevention, how to prevent and how to mitigate. And inspection and monitoring falls under topic number ataupun section number 7 for each damage mechanisms. So today we will covering number 5 and number 7 basically. But on the overview ataupun entry level view sajalah. Okay, this is the one that I mentioned before in API 2011, 571 2011. It categorizes into two bigger groups, which general industry and refining industry. So this is specific for refineries, and this is applicable to all industries sebenarnya. So this is again, I highly recommend kalau nak belajar API 571 early stage, open up API 2011 for a better understanding ataupun a better overview of the whole 67 damage mechanisms. Ada banyak Okay, I just tried to share you guys. This is how I rearrange the damage mechanism into my own understanding. So from the 2011 API plus to 2020, so ada some changes there. So I tried to regroup the damage mechanisms into these 4 categories just for study purposes. Masa nak ambil exam itu. So how I want to structure my brain and restructure my brain, I try to categorize it in terms of how it looks like, how the morphology will occur if that damage mechanism is there lah. So I have like environmental thinning, environmental assisted cracking, high temperature, and mechanical metallurgical degradation lah. So I know that whenever it falls under here, it only happens when the temperature is more than 400 Fahrenheit, ataupun kalau kita convert dalam Celsius is 204 Celsius. Okay, so for the purpose of this training today, let's just try to recategorize it into 3 bigger group, which is thinning, cracking, and metallurgical degradation. So for thinning, we will cover a little bit on uniform, localized, pitting, and crevice corrosion. And then cracking, we have environmental cracking and SCC, stress corrosion cracking. And then some metallurgical degradation in terms of metal leaching and metal weakening. Again, this is just a very, very basic overview of those damage mechanisms. Sebab kalau we go very deep, it's going to be very hard lah. So again, I think somebody asked just now pasal how general corrosion ataupun how one equipment boleh berkarat walaupun dia duduk dalam satu equipment yang sama kan. So I mentioned again just now in topic 1, we talked about concentration cells, and one of the basic corrosion cells. So when you have concentration cells, the whole maybe the whole structure ataupun the whole equipment will be susceptible to uniform corrosion ataupun the morphology will be uniform corrosion. But some sites in your whole metal structure ni akan ada a distribution of anode cathode yang very uniform. So maybe you have some part anode, some part cathode, anode cathode, anode cathode, but it is distributed evenly. So memang evenly. So that's why you have a general corrosion. Dia akan berkarat secara smooth lah. You will have a smooth type of corrosion happening there. But let's say when it comes to localized corrosion, you will be having some damage that will happen locally. One part is fixed to become the anode, and the rest is cathode. So this is how localized corrosion occurs ataupun happens lah. Okay. So let's say how a uniform corrosion and uniform type of corrosion, but it can be localized. So let's say this is my pressure vessel coated warna biru, but if it is made by carbon steel, and so you know carbon steel will rust and will corrode. Dia akan form that ferrous hydroxide. So katalah you try to protect the area kan, you try to isolate ataupun you try to eliminate corrosion daripada terjadi kan. Masa corrosion prevention punya stage, you tambah coating. But then further when you are in service, coating dah start damage ataupun degrade. So when the coating damage, katalah satu part akan ada corrosion ataupun coating defects. So that is where your so-called uniform corrosion last kali akan jadi localized. Sebab the part where your coated area damage tu, coating damage tu akan menjadi anode. The rest akan jadi cathode. So the rest tak exposed. The rest dah being eliminated from corrosion. So your area where you have the coating defect tu is not protected right now. So that's why dia akan jadi localized corrosion. So that place will become the anode. Understood?
Ada yang bertanya lah kan, regarding on the CUPS. So macam mana kita nak prevent ataupun reduce lah CUPS ni daripada terjadi, sebab this quite a common issue happening dekat onshore dengan offshore tu sendiri.
Okay, somebody yang tak tahu CUPS apa, bukan cup cup tu cawan untuk minum air kan. But CUPS is corrosion under pipe support. Okay, CUPS. So CUPS, I don't think you can eliminate it unless you are using, tapi kalau you pakai stainless steel pun boleh jadi kan, sebab akan ada pitting. But again, that is actually not uniform or localized corrosion. Itu kita panggil crevice corrosion, which we will cover a little bit later. Tapi tak apalah, kita boleh, okay, jap. Nanti kita cover sikit pasal crevice corrosion. I akan cerita pasal CUPS tadi. Boleh?
Okay, boleh. Dan ada satu soalan regarding macam tuan share tadi, macam vessel yang mengenai kita kata uniform corrosion ataupun localized corrosion. So macam ada one of participant tanyalah kan, sebab macam this thing is quite subjective lah in term of the uniform of the cathode and anode tu. Jadi ada ratio ke usually, macam nak differentiate between localized dengan general corrosion tu sendiri?
Ada actual ratio tu I'm not really sure, because I think it is more to metallurgy punya expertise. But I think it is an even distribution sebenarnya kalau you ada uniform corrosion. But if you want to say how severe a corrosion can become, is actually depending on the cathode anode ratio sebenarnya. So katalah you have a cathode, I would just show that the coated area is a cathode and this is your anode. So if let's say your anode is small, your cathode is big, you will experience a very severe corrosion. Okay, but if your anode is big and your cathode is small, you will have a less severe corrosion. Kita try to see it in an analogy. Katalah you ada RM1,000, you nak bagi kepada satu rakyat Malaysia, sakit tak? Sakit lah kan? Tak cukup duit kan? RM1,000. Tapi kalau you ada, I don't know, 8 bilion ataupun 30 bilion ke, you nak bagi duit kepada satu rakyat Malaysia tu, dia akan jadi less sakit lah sebab you ada banyak duit. So if your anode is big, you can contribute more to the cathode. Tapi if your anode side is small, dia akan makan makin dalam lah. Sebab you punya area exposed to small je. Sebab you kena ingat, corrosion berlaku dekat surface saja. Dia tak akan tiba-tiba berlaku kat tengah-tengah ni. Dia tak akan ada exchange of ions kalau tiba-tiba you duduk dekat ni. Tapi dia akan ada pengaratan when at the surface of the exposed metal lah. So if your anode is small, your cathode is big, then you will experience a much severe corrosion. If that can, yeah.
Kita boleh quantify ke tuan in term of the anode and cathode tu?
Anode cathode sites ni saya sendiri pun tak reti lah nak identify dekat site macam mana kan, but dia ada cara lah sebenarnya. Kalau you ambil kalau macam CP, dia boleh tengok where the current punya direction goes lah. So that is how they know where is cathode, where is anode. Tapi kalau just a bare metal, I don't think that you can identify where is your anode and where is your cathode lah. But macam saya cakap, kalau you coating satu part of it and you expose satu part of it, obviously ia akan jadi tempat yang anodic lah. Because it also depends macam-macam sebenarnya. Dia akan depend pada your oxygen level, your pH level. So dia very complex lah. Again, dia natural punya phenomenon kan. Cuma sorry, I cannot really answer that. Maybe a metallurgist can, but I cannot really identify that lah.
Alright, sure. Tuan, no problem.
Okay. Thanks for the question, by the way. It makes me wonder. It will make me wonder. Okay, let's go to the next one, which is pitting. So pitting ni, you will normally hear pitting in stainless steels. So stainless steel, it is actually a localized corrosion, and it will form small pits or cavities on the metal surface, and is commonly caused by chloride ions. Okay, so when it comes to chloride ions, it is much more prone for stainless steels. Okay, why pitting is very dangerous? Ada siapa-siapa nak cuba? Ada tak? Siapa-siapa nak cuba? Why pitting is dangerous?
You guys can answer in the chat box. We'll escalate to Tuan, Coach.
Okay, tak apa. Kalau tak ada orang nak cuba, I can just straightly answer lah.
Alright, sure.
Okay, tak apa. Kenapa pitting is very dangerous? From
Jadi sorry Tuan Coach, saya terus ramai yang nak mencuba.
Okay, cuba.
Is that can cause rapid damage?
Okay, lagi?
Ada yang kata is it depth or metal loss can be significant, ataupun it can ada yang menjawab is it can prone to crack ataupun lead to crack, and also susah nak detect kat mana ke apa.
Okay, good try everyone. Actually semua tu betul. But one thing yang maybe somebody tak mention is it can be misleading. Betul, whatever yang you guys mentioned tadi tu is true. Dia boleh prone to crack, dia boleh jadi crack, dia boleh jadi the depth can be catastrophic. Dan sebab you dah katalah this is your wall of the vessel, tinggal banyak ni je your wall remaining. So dia akan tak cukup untuk tahan internal pressure ataupun internal stress. But what is more dangerous is actually it can be misleading. Kalau you tengok dari luar, katalah you tak nampak the depth of the pit kan, you akan cakap kecil je sebenarnya damage kat sini kan, it's very small je, but the concern is actually on the depth. So bila the depth, you know that there are only less wall remaining underneath kan, and kalau you tengok sini dah start poros kat sini kan, so it can impact to your mechanical properties lah ataupun mechanical strength. So thank you everyone for trying. Really appreciate it. Bagus.
Ni Cik Amirul pun dia rasa dia bagi quite dekat jawapan. Dia kata susah tu nak tahu depth fitting tu.
Yeah, exactly. Memang takkan susah lah, memang takkan dapat exact pun. Maybe you can try using phasor array kalau dapat kan, but it's very hard lah. Sebab you have to remember pitting is a very small diameter but a very big depth punya area. So from any point of view, kadang-kadang kalau you buat UT pun might be tak dapat sebab it's very small area, you tak dapat. Okay, thank you everyone for trying. Okay, and then we have crevice corrosion. Okay, this one yang kawan kita yang tanya pasal CUPS tadi, corrosion under pipe support. This is similar to CUPS. How it happens is actually it occurs in confined space. Confined space ni bukan yang you masuk confined space vessel tu, but a confined space is a very tight space, tempat yang very kecil, very narrow. So what happens in that confined space is actually your level of oxygen here is much lower than the level of oxygen outside. And so bila you have these different oxygen levels, that is where you have that deaeration. They call it deaeration. So tempat yang less oxygen tu akan jadi anodic, and tempat luar ni akan jadi cathodic. Sebab tu corrosion is a very interesting topic. It's, you think that you know it so well, actually you don't know corrosion sebenarnya. You tak boleh nak expect. But what you can do is actually mitigate lah and control kan, and detect. So that's why engineers are here lah. So kat sini the very tight space ni akan ada very low level of oxygen, and if it goes to stainless steel, kat sini akan ada some chloride attack lah, and kat bawah ni sebab oxygen dah tak ada. So chloride presence dia akan makan you punya besi. So what happens with CUPS benda ni akan still terjadi, but it's very hard for you to eliminate it, because when you have CUPS, normally it's because your pipe is actually resting on pipe support, betul tak? So let's say you have a pipe support here, you try to rest your pipe here kan. So kalau you tak rest your pipe is experiencing stress, high stress kan. Kalau you ada pipe support tapi dia tak resting baik, you tak payah ada pipe support. So the function of pipe support is actually to make sure your pipe rests on it. So you ada Teflon pad kan, you ada but maybe I think the Teflon pad can actually eliminate that, sebab bila you ada that insulation ataupun you ada that rubber punya material tu, mungkin not so much corrosion yang akan berlaku lah. And I don't think akan ada corrosion pun sebenarnya. Yes. Tapi kalau pipe metal to metal seat and dia duduk atas tu, obviously dia akan ada CUPS. But I think one of the way is
Oh, sorry. Cik Nazmi ada tanya, so yang maksudnya CUPS ni boleh kita kata consider ada atmospheric corrosion lagi kan?
Yes. But actually it's okay. In API 571 sebenarnya it doesn't falls under atmospheric corrosion, but it falls under concentration cell corrosion. Even crevice corrosion ni, it falls under concentration cell corrosion. Because when you talk about concentration cell, it's all about the oxygen level rendah atas tempat luar, dekat tempat sempit tu rendah, ataupun you have chloride yang menyebabkan pH level turun. So it falls under concentration cell corrosion kalau you nak buka API 571.
Alright. And also macam tadi bila tuan ada mention mengenai putting a silicone pad or rubber pad, so macam ada Cik Omar tanya lah, so macam during design stage tu sendiri kan, macam mana in term of inspection punya perspektif untuk kita avoid this pitting dengan crevice corrosion waktu design stage tu?
Okay, dalam design stage tu, okay, obviously coating is one thing. Sebab tu I rasa kalau yalah, sebab, tapi coating pun lama-lama dia akan damage sebenarnya. But I believe if you properly place your Teflon pad, coating tu you buat betul-betul, and tapi again when your equipment has been operated for so long, it's very hard for you to maintain all these cosmetic punya thing. So whatever you can cater in terms of design, that's why you have the maintenance team to make sure that it is being sustained. Kan? So bila design stage, you boleh letak coating, but how long can that coating last? Kalau dalam one of some client punya RBI, coating life is actually only 10 years. 10 years tu pun, if you properly do your surface preparation, you use the proper procedure, then you get 10 years. But sometimes if you don't do it properly, maybe you dapat 5 years ataupun 2 years saja. Because again, coating as a theory is a very good preventive punya way, but in terms of practices, ramai dia orang yang suka ambil shortcuts lah and tak perform surface prep elok. So bila you design, maybe you design 20 tahun, tapi mungkin tahun kedua dah nampak dah coating kopak-kopak kan, terkopik-kopik kan. So in terms of design stage, you can try again, ataupun you boleh tukar material lah kalau you kaya kan. you can use, I don't know, stainless steel all the way, tapi still you akan ada subject to some chloride attacks lah kalau you duduk dekat marine environment. Tapi kalau you duduk dekat dry area, you nak pakai stainless steel, you cukup duit, buat lah kan. Okay, alright, so let's go to the next one, galvanic corrosion. I think kita dah agak terlewat ni, kita kena cepat sikit. Okay, so again we did cover this on the basic definition of corrosion cell tadi. So again, galvanic corrosion is actually bila you ada dua material being connected ataupun contacted with each other, and one material is more noble than the other. Okay, how you want to define more noble? You buka the galvanic series and you see where is the hierarchy lah. So the most common galvanic corrosion is actually carbon steel versus stainless steel. So you see that stainless steel is much more cathodic than carbon steel. So carbon steel will corrode, will corrode in this case. Tapi kalau you letak magnesium dengan carbon steel, magnesium yang akan corrode. Okay, so magnesium, sebab tu bila kita pakai kita kata buat CP kan, sacrificial anode is these three, typically tiga material ni lah, magnesium, zinc and aluminium, sebab dia akan protect carbon steel. Okay guys, sorry terpaksa lajukan sikit sebab takut tak sempat cover NDT. Okay, and then we have impact corrosion. So impact corrosion is where you have corrosion yang akan berikan mechanical wear or abrasion, so from your flow. So basically it's a flow assisted corrosion. So where you have flow, katalah you ada liquid ataupun you ada some solid particles in your flow, then those particles or liquid will impinge ataupun akan langgar your wall lah, pipe wall. For in this case, normally kalau ada U-bend macam ni adalah your heat exchanger lah. So dia akan langgar, dia akan makan all this part yang kat belakang. We call it extra DOS lah. So the extra DOS area are always being impacted lah. So menjawab satu soalan tadi, I think somebody asked about piping piping punya corrosion. So when you know that your damage mechanism will have impact corrosion ataupun erosion corrosion, so always focus on your thickness measurement ataupun you buat RT profile ke dekat belah-belah tepi ni. So obviously kalau secara logik teori pun you tahu dia akan makan kat tepi ni lah. We will touch that on topic 4 nanti. Okay guys. Okay, then we have intergranular. Okay, so these are cracking punya, kita dah masuk part cracking. So thinning mechanism tadi dah cover. So on the cracking part, kita ada dua type of cracks lah sebenarnya. Intergranular and transgranular. So intergranular ni basically they will experience crack in between the grain boundaries. So you nampak macam hexagon is the grain lah. And ni bukan madu Dia bukan yang apa tu, sarang lebah tu. Dia panggil apa tu lupa dah. But it's a crystalline lah, kita punya crystal grain boundaries. So your crack will go through the grain boundaries. So this is when your grain boundaries start to weaken and it start to fall apart lah. So that's why your crack boleh berlaku dekat this part. Okay, and some damage mechanism ataupun banyak damage mechanism yang akan beri you transgranular punya morphology. So this is much worse than this one obviously, sebab dia punya crack can propagate through the grains. So dia dia koyak dekat dalam grain tu sendiri. In between grains pun dia boleh go through. So it means that your metal is already weakened lah. Not just the boundaries. Kalau yang ni dia punya boundaries yang dah weaken, but kat sini the whole metal part tu dah start to weaken lah. Okay, so intergranular corrosion. Okay, yang tadi kita tengok pasal intergranular fracture ataupun cracking. So this is where intergranular corrosion comes into place. So it can be due to your environment assisted cracking lah. Katalah you ada your product kat luar tu apa, ammonia ke, you ada chloride, and chloride one of it is chloride with stainless steel, tak boleh. So dia akan makan on the boundaries, it can corrode on the grain boundaries. Okay, so what happens when there's intergranular corrosion? It reduces the strength of that particular metal lah. Okay. Yeah, and then this is same to previous. So it is part of environmental cracking. So you nampak dia akan patah dekat grain boundaries lah. By the way, the photo is credit to Corrosion Atlas punya book. Dia ada banyak case study kat situ. I really recommend you guys to find that book and read through lah. It is a very good reference for corrosion. And then we have stress corrosion cracking. So stress corrosion cracking, if you look at the morphologies, it is basically a type of cracks that has branches. Kalau kita tengok gambar ni dia ada branch. Tak sure boleh zoom ke tak. Tak apalah, tak nampak. Tapi kalau kat sini nampak ada branch. So bila ada branches ni, most definitely it is due to stress corrosion cracking. Kalau yang tak ada branch, macam ni, sometimes tak ada branch tak ada branch, maybe it can be due to corrosion fatigue ataupun ni ada tulisan corrosion fatigue ataupun embrittlements. So embrittlements dia akan fail dekat you punya grain boundaries lah. Okay, and then selective leaching. This is part we are at the metallurgical degradation part. So when you say selective leaching, if let's say you ada alloy ataupun our besi ni sebenarnya, bila mana-mana besi pun kita ada, it is not pure ferrous. Dia bukan ferrous sahaja. So dalam tu ada campuran-campuran alloy. So what happens with selective leaching ni, maybe due to process you ada a certain temperature, dia akan start to buang some alloys. Sebab alloy ni, setiap alloy dia ada different temperature, what do you call it boiling point. Is it boiling point or melting point? I think melting point. So bila dia ada different melting point, dia akan start keluar lah at a certain temperature. So if let's say you have brass, B-R-A-S-S, brass, bukan beras. Beras nasi kita makan. Brass dalam bahasa Melayu panggil apa? Tembaga tembaga is copper. I forgot. Tapi brass is actually zinc and copper. So the zinc akan keluar. So dalam API 571 they call it dezincification. So dezincification, dia buang zinc. So tinggallah copper semata-mata kat dalam tu. So that is part of selective leaching. Ataupun you punya carbon, kan, you punya carbon steel, carbon tu hilang, decarbonization. Tu pun sama juga. It is part of a selective leaching punya morphology lah. So what happens when you have this selective leaching? Akan ada a porous ni maknanya ada lubang lah. You punya metal tu daripada solid, dia akan ada lubang where your alloys were there before, and dia akan weaken your mechanical strength. So dia reduce in strength kat sini. Alright. Okay guys. Dah pukul 11. Everyone okay as of now? Sorry terpaksa percepatkan sikit yang belakang tu. But don't worry, we will again cover it back in topic number 4. Everyone okay?
Everyone is okay.
Okay, good. Okay, let's jump quick. Tapi sebenarnya this topic is quite extensive. But if let's say you have some basic knowledge in NDT ataupun inspection, this is going to be a little bit orang kata easy, bukanlah easy lah, but okay sikit lah for you to understand. But if you are very new to NDT ataupun inspection, it is going to be a little bit heavy, but I hope you guys can be with me, and tak apa kalau kita try, kalau ada soalan you boleh tanya lah. So basically, inspection examination methods and technique. Here I will also try to share some of my experience when previously doing NDT itself lah. So tadi saya ada sebut kan, saya ada some background in NDT back then. So I started my career in NDT sebenarnya. So here I try to share whatever I can in terms of inspection and examination methods. But okay, before that, how do we detect corrosion? Sama-sama nak try. Sebenarnya saya dah bagi jawapan dah tadi. Okay, how do we detect corrosion? Tak apa, kita proceed je. How do we detect corrosion is actually by performing inspection ataupun performing examinations. Okay, kalau you tengok tajuk dia pun inspection / examination. But what are the difference between these two terminologies? Kalau dalam API, be it API 510, API 570 or 653, but if you see in the slide, I banyak quote API 510 sebab just because of popularity. Sebab 510 ni a bit popular than others lah. So how API as an organization differentiates inspection and examination. Dalam erti kata lain, inspection ini adalah inspector API you yang buat kerja dekat site. We call them authorized inspectors. So they perform inspection. And how they perform inspection? They do it by visual lah. Kan, by visual inspection, by performing some measurement, and dia buat gauging dia tengok ada rosak ke tak. Kalau yang berani sikit tu dia akan start ketuk-ketuk dengan hammer kecil ke, ataupun pakai scraper. So those are inspectors and those are inspection. But when it comes to NDT ataupun NDE, non-destructive examinations, that is where the terminology examinations comes lah. And so the right definition is investigate a component of the pressure vessel using NDE. Kenapa dia sebut pressure vessel saja, tak sebut piping? Because it is under 510. Tapi you can use this terminology in piping, in tanks, in whatever structure lah. Cuma spesifik kat 510 dia memang sebut lah pressure vessel. So examination, again, NDT, NDE. So from ASME 5 itself, the definition is technical methods to examine materials and or components in ways that do not impair future usefulness and serviceability. It's quite a mouthful to say, but in a layman's word, if you don't destroy that material, if let's say I want to perform NDT on my tumbler, because takkanlah saya nak destroy my tumbler kan, nanti tak adalah tumbler untuk saya minum. So I can perform NDT, a non-destructive testing ataupun non-destructive examination. Okay, so untuk locate, sorry, lupa nak tambah. Order to detect, locate, measure, interpret and evaluate flaws. So basically we are trying to detect the flaw is by not destroying your component ataupun equipment. Okay, sorry nampak kelang kabut sikit, but this is just a so-called mind map. I just put the orang kata abbreviations. So you have conventional methods, you have advanced methods. So for conventional methods, you have visual testing, penetrant testing, magnetic testing, radiographic testing, ultrasonic testing, and eddy current testing. Sorry. And for advanced, I try to categorize it through to the application, which is well inspection. Untuk buat well inspection, you use phase array UT and time of flight diffraction, TOF and POUT. It always comes together. And then for CUI, corrosion and insulation, there are some advanced technology such as pulse eddy current (PEC) and guided wave testing. For HEX is heat exchangers. So you have all the tube testing techniques. So this is where my previous experience were lah. So I was more on the tube testing and also guided wave. So I pernah buat lah all this. Okay, just for some conventional NDT ataupun NDT methods. Based on ASME 5, you have Article 2, radiographic examination, Article 6, Tengok yang bawah artikel yang atas ni is 1, 2, 3, 4, 5, 6, but article is depending on which NDT methods. So article 2 is about RT ataupun radiographic examinations. Article 6 is PT, penetrant testing. Bila you pakai NDT ataupun NDE ni is interchangeable punya terminologies. It's just that quite recently ASME 5 shifted from NDT to NDE. They follow API punya terminologies. Because why? Because they are Americans. They try to copy each other kan. They nak try to contain dia punya industry. So our industry we still use NDT. So kita still pakai RT, MT, PT, UT. Cuma dalam ASME code dah jadi E belakang lah instead of T. And so bear with me kalau I sebut NDT ataupun whatever terminologies ada T tu, it means the same. Okay, and then we have Article 7 MT, Article 9 VT ataupun visual, Article 23 ultrasonic examination UT, Article 8 on eddy current. Do you guys want to watch a video?
Boleh rasanya.
Boleh sebab I think walaupun dia 3 minutes, tapi the 3 minutes tu akan banyak sum up the conventional NDT. Kita akan tengok je lah. Boleh dengar?
Boleh.
So Camilla, we're here to talk about NDT. Could you explain its purpose in Formula One and exactly what it is?
Yes, of course. NDT stands for non-destructive testing, which is a branch of engineering concerned with all the methods for detecting flaws in the materials. We utilize 4 methods in the factory. This one is ultrasonic inspection. So this equipment uses high-frequency probes that emit ultrasonic waves into the material under the test. Sound wave travels all the way through, gets bounced back from the back wall, comes back to the transducer, and this equipment transformed ultrasonic wave into electrical signal that's displayed on this.
I thought it would only be scanning the top surface and not looking right through it to something potentially inside the carbon fibre or even on the other side of it.
Yes, ultrasonic is used to detect indication internally. So it's not just scanning the surface of the part, it's just scanning all the way through.
What is this machine for then?
So the other set is eddy current set. Eddy current is a method that utilizes magnetic field. So this little probe contains a coil. Through the coil runs a current, producing magnetic field. This set is tracking the changes in the magnetic field generated by the eddy current in the metal.
The imperfection is changing the magnetic field.
So once we hit the indication that we think it's a defect, this set will record it.
Wow, so it's studying parts of the car that could potentially have failed that you can't really see with the naked eye. So there are 2 other processes to this.
We've got 2 other methods. Let me start with dye penetrant inspection. It's a method that is used to reveal surface breaking indications by bleed out of fluorescent dye from the floor. This inspection is carried out in a dark room under the UV light.
That's a vision-based method, but with the help of UV light. What about the other process?
Another one is magnetic particle inspection. It's a method that reveals surface breaking defects by utilizing the magnetic field. The magnetic field is applied into the component, then the part is magnetized by running the current through the part.
So is that like a bigger version of this then?
It works on a similar principles because it uses a magnetic field.
It's proper science, isn't it? It really gives me and other drivers out there peace of mind to know that when we jump into the car and drive the thing at over 200 miles an hour, that it's been thoroughly checked. And like I said, I wish I had learned this many years ago. So thank you very much for this very detailed explanation.
Okay, alright. So not just oil and gas pakai, even Formula One pun pakai Mercedes. But I really like the closing there. Dia kata it's proper science. Sorry lah, saya punya slang tak sama macam dia kan, sebab kulit pun tak berapa nak cerah kan. But they said it's proper science, isn't it? So again, NDT is not magic. Sometimes in the industry, people always treat NDT as it's like magic. Dia kata NDT boleh detect every single thing, but it's actually proper science. It's just science and technology. And when you talk about science and technology, it's all about limitations. It's all about capabilities of what the technique ataupun method of the NDT is being implemented lah. Okay. Tak boleh nak tekan. Okay. So my question is, what is the most common NDT method performed? Anyone wants to try? Apa most common NDT method being performed?
Alright, UT. Ada yang menjawab UT, ultrasonic visual testing. Cik Farhan cakap.
Okay.
Cik Aziz cakap general is conventional type.
Okay. So Cik faham betul lah. Visual testing is actually the most common NDT method being implemented in the industry. Because why? The only reason is actually seeing is believing lah. And so katalah you nak dapat gaji kan, bila UHR kata gaji dah masuk, you still akan buka account bank you untuk check betul tak? Ataupun finance you cakap gaji dah masuk kan, you akan tengok account bank itu berubah nombor ke tidak, barulah you percaya. So similar to NDT, always ataupun dalam industri kita, always seeing is believing punya approach. So that's why whenever it comes to code and standards, whenever you determine ataupun whenever you inspect anything using visual inspection and you found a defect ni maknanya dah lebih daripada tolerance limit, you will have to reject that particular equipment lah kalau you jumpa through visual. Sebab visual alone can supersede any other NDTs, sebab seeing is believing lah, itu you nampak benda tu kan. But when it comes to other NDT methods, bila you buat, might be some variables ataupun factors impacting to the result that you are, ataupun the indication that you get from that NDT method. So when you perform visual inspection, it is orang kata ultimatum lah, the ultimatum bila you buat visual inspection. But can you perform visual inspection all the time? Might be not. Might be yes, might be no. Sebab sometimes you tak ada access, you tak boleh masuk. That's why you have to depend on other NDT methods as well. Okay, so this is just a visualization. Siapa yang follow LinkedIn saya before this, you might have seen this before. So basically the diagram is from API 577. API 577 pun ambil daripada somebody, I forgot his name. I think Jefferson, is it? So he took it from that guy and put it in the code and standard lah. Dia reference there lah kan. So this illustration sums up most of the requirements of visual testing in accordance with API ASME 5, ASME section 5 NDT. So your eye position cannot be lower than 30 degrees. Must be more than 30 degrees. You tak boleh buat inspection flat to the surface, and not closer than 6 inch. Your position between your surface and your eye. And then the maximum dia bagi adalah 24 inci ataupun 2 kaki lah, 600 mm. And your lighting must be 1000 lux. Again, these are technical requirements you must adhere to during your examination ataupun you punya inspection punya masa lah kan. Because everything is science and technology kan, dia kata is proper science, so we have to put it in a very procedural technical requirements. So these are the requirements of visual testing.
Tuan Kush, ada Cik Arifin macam curious lah tanya. So actually NDT dengan corrosion ni apa relation between both of them? Dan kalau NDT tu macam mana kita nak pilih method NDT, dan adakah dia disebabkan for specific corrosion ke macam mana?
Alright, I'll answer that in the next topic ataupun the last topic kita lah, topic number 4. Boleh?
Oh, sure.
Okay, thank you for that question by the way. Mungkin tak nampak kan, tiba-tiba cerita pasal corrosion, tiba-tiba cerita pasal NDT kan. This is actually the bridge to the final topic lah, ataupun the final topic will be the bridge between two topics. Okay, we'll proceed with the next entity. Kalau kita dengar tadi penetrant examination ataupun tadi dia panggil dye penetrant inspection, the same thing. Dye is DYE bukan DIE. DIE itu mati. DYE is dye lah, macam nila I think kita panggil nila kan. Okay, so step 1, you have to clean the surface pakai contact cleaner. So that's why supaya all the dirt and oil being removed. And then you have step 2, you ada penetrant, normally warna merah. This is for the contrast technique. Tapi ada satu lagi teknik kita panggil fluorescent technique. Fluorescent technique dia akan pakai dye yang boleh glow in the dark, ataupun bila kita letak UV light dia akan jadi warna fluorescent. So again, bila kita sebut fluorescent technique ni is much more sensitive than the normal one. Okay, normally kita buat dye pen ataupun penetrant inspection pakai red dye ni lah. And then the dye akan penetrate into your crack, and dia akan masuk dalam tight crack using the concept of capillary action. Macam straw kalau you ada straw, how straw works is capillary action. And then step 4 is you wipe off excessive penetrant, mana yang lebih-lebih ke atas ni tadi you wipe off, so you will only remain the one inside the cracks alone. Okay, and then you put the developer ni bukan orang yang buat rumah tu bukan developer rumah, but it's a white it's like bukan chemical, dia macam powder. Developer powder is a white powder. When you spray it when you apply it on the surface of the crack mana yang kita letak penetrant tadi, and you give it some time, dia akan bleed out. Dia akan suck out balik all the penetrant kat dalam your crack ni tadi, and it will give a bleed out indication lah. Why you call it bleed out? Sebab dia nampak macam darah. It will literally look like blood. Warna merah kat atas tu. Okay. So I try to sum up in a very visual step by step punya ni lah for you to understand. Okay, the next one is MT atau magnetic testing. So when you have a magnet, you guys know how magnet works, right? Ada siapa-siapa sini tahu tahu tak magnet berfungsi macam mana? Okay, tak apa. So when you have two poles, kutub magnet ni ada kutub, poles north and south, and you put it on a piece of metal, and it will still replicate the north and south punya kutub lah. When you have a permanent magnet. But what happens when there is a crack here? So bila you ada crack, dia akan the part is magnetized, maknanya the whole structure is magnetized. So when you have a crack here, your magnet poles akan berubah. Dekat crack ni, satu akan jadi south, satu akan jadi north. So if let's say you put your south pole here, dia akan jadi north ni dah, and your north pole akan jadi south. Sebab concept of magnet let's say I have, you bayangkan this is a one piece of magnet, and then I break the magnet into two, dia akan jadi a singular magnet alone, and this one akan jadi a singular magnet alone. So daripada north and south, katalah I have north and south, when I break the magnet, I will have north south. Dua-dua akan ada their own poles. So it's similar to our crack. So bila ada crack, dekat tempat crack tu akan ada a break of your magnetism lah. So one akan jadi south, one akan jadi north. So here the magnet will be very very strong. Your magnetic field akan jadi paling kuat kat sini lah. So what happens, we put the iron particles at near the area of interest ataupun inspected areas, and your iron particles akan berkumpul ke dalam crack ni lah, and it will give you an indication there is a crack. So if there is no crack here, your magnet particles akan disperse here and there lah. So dia tak akan pergi lah, dia tak akan berkumpul di tengah-tengah. Sebab your magnetic fields here is the strongest bila you ada crack. Okay, lupa nak cakap. When you have magnetic testing or penetrant testing, your visual requirement is still 1000 lux macam visual tadi. Okay, and then we go to the next one, RT, radiographic testing. Okay, tadi kita tengok on the surface breaking defects. So now let's look a little bit on the subsurface. So when it comes to RT ni the concept dia sebenarnya it plays around with the density, bukan plays around lah, but it measures ataupun it gives an indication based on density. So the keyword here is density. So whenever you have a more dense material and a less dense material, the view of your RT film akan be a little bit different lah. Okay, just some concept. Tempat yang less dense ataupun kalau you ada satu metal piece yang sama, kata ni besi, so when you have different thickness, this will be less dense than this one. So the less dense ni tumpat bukan dense menari, but dense tumpat. The less dense material will be darker. Dia akan keluar gambar yang sangat gelap. Lebih gelap. But when it comes to a more dense material or a higher thickness material, you will see a much brighter image on the RT film. Okay. Put a concept, you buat x-ray badan dekat you punya chest kan, you letak dagu you apa semua kan. So apa yang you nampak dalam x-ray tu adalah your tulang, because your bones and tulang kita is much dense. It's denser. Is it denser or more dense? More dense. It's more dense than your kulit, your isi. And sebab dia punya material tu tulang. So that's why you only see your bones dekat x-ray image you. You tak nampak lah you punya tai lalat ke, you punya dimple ke, tak keluar dah dalam RT film kan. Okay, that's the concept That's the concept. So let's say you have a similar thickness, satu thickness sahaja, tapi dalam you punya thickness metal tu ada different kinds of things lah, ataupun defects ataupun imperfections. So let's say you have a single porosity, cluster porosity, a crack or a tungsten inclusion. So when you say porosity, dalam dia adalah what medium? It's just air, kosong, lubang je kan. So dia akan jadi less dense than the metal. So metal ni dah tumpat, and then you go here dah jadi kurang tumpat. So you will find a very dark image circle lah kat sini. Sama dengan crack akan menyebabkan your material be less denser than the base metal ataupun the place where there is no defect. So you will see a crack like image indication kat sini lah. And kalau welding, you have tungsten. Tungsten is actually a denser material comparing to carbon steel. So that's why tungsten akan nampak lebih cerah di dalam your RT film. This is for RT welding, just to give some idea to you guys. But the same concept when you apply it to whatever RT that you're going to do lah. And the limitation is actually on cracks. When it comes to cracks, if it's a perpendicular crack, if it's a perpendicular crack to your thickness, you akan nampak. If it's a parallel crack to your thickness, dia akan tak nampak. Okay. You guys think that my statement is wrong sebab ada tulis kat sini kan? It's actually perpendicular to the radiation direction. So you nampak direction dia akan tembak ke bawah. So this indication is detectable. The crack number 1 is possible to miss lah. So crack number 1 ni normally susah nak jumpa when it is horizontal. Sebab when your radiation source lalu dekat crack ni is very insignificant, and then dia akan lalu sini. Tapi whatever comes here, dia hanya dapat detect half thickness metal lah. So that's why you can see the crack indication on your RT film. Okay, let's go on to the next one, UT. So UT basically is ultrasonic. So this is actually the ultrasonic range of your NDT. Okay, so normally UT is 20 kilohertz and above. And how it works is similar to our animals yang kita ada, dolphin, So dolphin pun pakai sonic waves. So what happens is dia keluarkan a sonic wave and it will bounce back from an obstacle object lah. And our submarines are also replicating these sonic waves. So that is how waves ataupun acoustic punya range tu being principle lah, the working principles. So basically for UT, we have several probes that are common being used, which are 0-degree probes, 45-degree probes, 60-degree probes, and 70-degree probes. So the first one is for UT thickness gauging, and the angle probes ni kita panggil angle probes yang ada degree ni. These are used for flaw detection lah. So this is thickness measurement. This is flaw detection. So how it works? So 0-degree probes, when you put it here, it will measure the time between your wave being bounced back lah, from the whole thickness. So let's say you put it at a defect-free metal, so tak ada defect, so you will get the whole thickness. And then if you put it at point B, it will hit your defect ataupun lamination here, and it would gives you a shorter reading lah, because it bounces back faster. And for this point, you will have two signals. One is on the lamination part, and one is on the full thickness range. Okay, and then we have flaw detection, angle probe. Well centerline, basically this is used for flaw detection, commonly used for welding inspection, tapi kita still boleh use for our in-service inspection, especially for cracks lah. Okay, and then we have eddy current. So eddy current, walaupun dekat dalam industri oil and gas is considered as advanced, but basically eddy current is a conventional punya method. So what happens is an eddy current is being being generated by your coil's magnetic field. So dia punya probe ni, dia dalam bentuk coil ni, dalam dia ada bentuk coil. So it will generate a magnetic field, and when it comes in contact to a metal, it will generate its own magnetic field, which we call it eddy current. Okay, how it works as an NDT. So let's say you have this eddy current, so your system will read it as this signal. But when it comes to a place where there is a crack, your eddy current akan berubah bentuk. Dia akan try to flow to a less resistance punya area, and it will give you an indication on your screen, macam yang tadi video kita tengok lah. Okay, and then in terms of API 571, there are several NDT abbreviations. These are what being mentioned in API 571. So I would say most of it is considered as so-called advanced. Shuib, can we take 2 minutes? Jap, I think I have to take a quick break. Yep.
Sure.
Boleh ke? Sekejap
Boleh, sure.
Sorry.
Baik, Cik Amil noted that you'll be leaving early. So thanks as well for your time, and I hope you have a safe travel and you can benefit it from this training lah. And for others, the one that after this we will have a certification for this training. So kalau yang mana yang not buy through the Stripe ataupun dengan yang bukan premium subscriber and also not buy through Stripe, please PM Cik Syed Idrus for the detail for the certification. Others we already got your detail when you buy through the Stripe lah. And premium subscriber we have your database for the cert. Thank you.
Okay, sorry guys. Alright, can we continue? I try to speed up this one because kita dah masuk ke advanced NDT.
Alright, sure tuan.
Okay. Because advanced NDT more or less is just trying to make whatever being conventional. They akan try to improve the technology and make it much. But they akan increase the capability of that technique lah. Okay. So first, if you always hear in the industry orang pakai phase array ataupun nama glamour dia PAUT lah, PAUT PAUT. So PAUT is basically just the normal UT method sebenarnya, but it's an advanced technique. And so when you talk about NDT ni yang tadi kita baca pasal artikel, we call it methods MT, PT, UT, RT, VT, ET, those are methods. But in each methods, there are technique dia. So there are several techniques. So phase array is actually an advanced technique. So what they do is your angle probe tadi tu, your UT angle probe, if the conventional method, there is a fixed angle. So katalah you ada 45 degrees kan. So the 45 degree tu dia boleh pergi 45 degrees sahaja. So when it comes to phase array, the probe ada depends pada how many elements, but normally we have 32, 64. So you just imagine you have 64 probe in a single probe. So setiap 64 element tu you boleh adjust dia punya angle. So that's why they call it advanced lah. So the coverage is much bigger than your normal UT probe. So katalah your left side is your conventional. So one single angle only can cover several parts, only the orange part yang dia boleh cover. But when it comes to phase array, it can cover the whole Wellman. So you tak payah nak go back and forth untuk scan lah. Okay, tak apa, we won't go to the details of using the technique because you guys bukan NDT operator. And this is not an NDT course, but if it's an NDT course, they will teach you much more deeper into the techniques lah. And every method ada cost lain-lain So again, we are trying to have a very quick crash course ni. So this is just a PAUT scan plan. So you see that the whole scan can cover the whole Wellman area lah. This is how the scan looks like. So if let's say you see something like this in the industry, then obviously it is a phase array. So tak adalah you terkejut tengok kan. Ni nampak macam ultrasound So kalau macam siapa yang ada baby tu, kalau you pernah tengok how the scan perut ada rupa macam ni kan. So basically macam tu lah. And this is what we call an S scan. Sectional. Okay, and then even for welding inspection ataupun weldment inspection, mostly they always try to pair these two together. TOFD, time of flight diffraction, and phase array. TOF normally tak pakai single use Dia normally akan pair with phase array. But how TOF works is they use a different type of UT technique. So tadi tu kita panggil pulse echo. Pulse echo ni you baca the same echo. You punya probe tu is transmitter and receiver. But this is a pitch catch method ataupun tandem method. One transmit and one receives. So satu bagi the sound wave, satu hanya receive the sound wave. So how TOF works, at the tip of the crack, they will give some indication to the receiver. So they only read the tip of the defect. So this is the scan plan, sama macam PAUD tadi. And this is the sample scan. Kalau you nampak a greyish scan, ada macam curve-curve. Dia kata frowning macam frowning, macam apa, mulut masam kan, frown. So these are how they read the scan. Sorry, I am not a competent TOEFL and PAUD punya practitioner, but what they tell me that all these indication tu boleh represent some of the diffractions from some crack tips ataupun whatever sharp edges inside the material. Okay, and then we have for CUI, Advanced NDT. So we will cover on two, PEC and guided wave. Pulse eddy current, secara jujurnya, I sendiri tak pernah buat sendiri. Tapi in the industry memang pernah buat lah, but I tak pernah operate on that one. Guided wave I pernah buat back in 2011. Is it 2000? Yeah. Sorry, 2014. Okay, so PEC is just this is the advanced method for eddy current. So how it operates is actually it detects wall loss on ferromagnetic structures, and it gives a volumetric measurement converted into average thickness measurement. Okay, apa dia buat? Dia hanya baca the well decay ataupun the well decay pula. Dia hanya baca the magnetism decay from your structure, and it will it will give you a conversion in terms of thickness. Dia akan buat benda tu dalam bentuk software algorithm in the system, and it will convert it into thickness measurement. So how it works, dia akan give a pulse, electromagnetic pulse. So it will penetrate through your insulation, akan masuk dalam your pipe. Your pipe is metal, your ferromagnetic. It can contain, it can absorb the magnetic field. Dia akan contain magnetic field tu, and then dia akan switch off dia punya electromagnetic. So when they switch off the electromagnetic, whatever magnetism residual inside your pipe akan keluar balik. So that is what they measure. So that's why they call it pulse eddy current. It gives you a pulse, not a continuous eddy current, just one pulse. So from your pulse too, it will determine whether how much magnetism has been contained in this certain area lah. So in this case, you have localized corrosion. So maybe the time of decay too is lesser than part here lah. Sorry, it's going to be a little bit technical, but that is basically what the technology gauge lah. Okay, I don't think I will show this video because we are actually short of time. But whenever you guys dapat the slide nanti, you can just press the link and you guys can see how PEC works. Or you can just Google ataupun YouTube PEC technology from Edify. There's a lot of videos of advanced NDT you guys can learn.
Alright, sure.
Okay. Sorry guys, we have to very speed up. Kalau tak sempat nak pergi ke next topic. So then we have guided wave. Guided wave is basically you pasang a clamp, UT clamp here, tapi cara dia buat UT is not through thickness, tapi your wave akan propagate through sampai quite a long range area lah. So dia akan hit an obstacle and come back to your collar here. So what the collar does is actually transmit and receive. So you can see here lah, gambar-gambar ni pun from Edify sebenarnya. I pinjam the gambar lah for explanation. Okay, this is the sample scan yang kita orang pernah buat dulu. I pernah buat dulu lah. This is where the collar sits. So when you shoot the long range UT ataupun guided wave signals, so dia akan baca several geometrical structures in your whole pipe. This is always used for long pipeline. So that's why they call it guided wave ataupun long range UT. So the defects are actually here lah, kalau kat sini. Jadi pun ada video dia. I think you guys boleh buka kemudian lah. This can explain. See, if you can see, there is a wave yang akan propagate through the whole pipeline. Yeah, and then last but not least, on the hex inspection, heat exchanger. So this is where heat exchanger techniques were being mentioned in API 571. So kat sini I dah identify siap-siap what are the techniques is used for which tubes. So we have iris, ferrous and non-ferrous. Eddy current is only for non-ferrous. MFL is only for ferrous, and RFT is only for ferritic tubes. So on your left side is air cool heat exchanger ataupun fin fan cooler. On your right side is the shell and tube heat exchanger, where we will inspect the internal tubes. So basically this channel head akan cabut and the tubes will be exposed and we will perform inspection inside the tube. So how it works is we insert our probe inside the tubes. So in this case, I'm just giving you a diagram of a air cool heat exchanger ataupun fin fan cooler, where you have a header and a finned tubes. So this is for MFL technique. MFL technique, they are the permanent magnet inside the probe. So it will magnetize the whole tube ataupun the area of interest. And the coils, we call it receiver coils, will read any indication if there is defect yang akan impact to your magnetic field. Okay, more or less in the layman term, there lah. But if you guys are interested, you guys can always search on MFL, magnetic flux leakage. There you can read through all the literatures of that technique.
Tuan Kush, ada two quick question.
Okay.
Yang pertama, in term of the accuracy between RT and UT, so which one is better? And soalan nombor 2 adalah the GWT tu boleh guna untuk pressure vessel tak?
Okay, good question. UTRT, there's no such thing that it's superior than the other, because the limitation, again, it's science, right? So limitation UT ada limitation dia, RT ada limitation dia. So again, always know what you want to see, what you want to inspect, and determine what techniques are much better to be used lah. Okay. One thing that I can say for RT versus UT is UT can detect the location ataupun depth of your defect. But RT, you cannot determine the depth. If let's say you have a true thickness, kan, kalau you ada true thickness, katalah this lubang is a defect, right? If RT, you can only see there is a defect here, but you cannot determine what is the dimension from your root ataupun you punya bottom ni. But UT, if you perform shear wave UT ataupun the UT floor detection, UTFD, you can actually detect the location of this floor in terms of depth. Macam tadi pitting tadi kan, sebenarnya pitting kalau is a very big pit, so you can determine the area ataupun you can estimate the wall loss there. Menjawab soalan?
Menjawab.
Okay. But on the GWT, guided wave technique for pressure vessels, I don't think you have a collar that big lah. So I don't think there's such ways to perform GWT for pressure vessels. Normally it's used for piping. Piping pun not so much, sebab piping ada banyak orientation kan. Kita ada elbow, kita ada reducer, kita ada T. So all the bands tu akan reduce the signal strength of that GWT wave. So the application is much more on longer pipes or a pipeline. Tapi kalau corrosion under insulation, yes, you can use it because you are interested in the areas underneath your insulation. So you hanya buka sebelah ataupun you hanya buka one portion of it, you can try to screen the whole length of pipe. Tapi masalah dia when you have a lot of bands, a lot of T's, a lot of reducers, kat situ akan jadi haywire sikit because your signal strength dah jatuh. So it's not suitable for vessels and not suitable for very complex orientation of pipings.
Alright. And also, I guess the one last quick question adalah tanya pasal iris, ECT, MFL dengan RFT ni semua boleh guna untuk band tube tak?
Okay, semua boleh pakai untuk the straight portion of the tube saja. The band tube tu normally is not covered by these probes sebab your probe ni is a limitation. Okay, the probe is actually a rigid probe. So when you go to the bend area, you punya probe dah sangkut, tak boleh masuk ke bawah. But I believe for a bigger diameter tube, I pernah nampak satu probe tu yang dia macam bulat-bulat. So katanya dia boleh turun sampai ke the bend area lah. But I'm not sure how effective that probe is lah. But normally we only cover on the straight area of the tube saja. The bend part tu is very hard for you to inspect. Orang kata boleh buat profile RT, but I susah lah nak buat sebenarnya profile RT tu.
Alright, Tuan. Thank
Okay,
you.
alright. Thank you for the questions, by the way, guys. Okay, where were we? Okay, that is MFL. So basically, on the layman understanding, it magnetize the whole tube, and kalau ada defect, dia akan kacau you signals, and that signals yang dikacau tu, you akan dapat dalam the screen of your equipment lah. I'm just giving you guys a very layman punya explanation sebab it's going to be very very technical kalau nak cerita on how it works. Okay, in terms of iris, okay, iris pula is using the UT method. Kan tadi kita ada method kan, UT, RT, MTBT. Iris ni basically you're using the UT wave. Tapi macam mana you buat, you kena letak air lah kat dalam ni. Because in terms of UT to work, you have to have a very medium kat dalam ni. So the medium is fluid, so fluid is water lah. Okay, then you have a small turbine here and it will rotate and gives you the wall thickness of every portion of your tubes. Okay, so this is the sample scan of MFL, a sample scan of iris. Again, UT, you boleh dapat C scan dia. This is what we call a C scan. So kalau kat sini, this is an actual case, I pernah buat dulu in Thailand. So kita jumpa external corrosion from the iris inspection lah. This is ECT, eddy current testing. So all of this is actually the baffle plate. So if there's kat sini kita jumpa satu pitting lah in between here. And then this is RFT, remote field testing. Okay. Sorry guys, I know this is very complex and very heavy for you to digest. But again, the intention is actually to give you some exposures ataupun a very generic exposures of advanced technology lah. Kita tak boleh cerita in depth on how it works. We can make it another topic if you guys want, but for today kita terpaksa cut short sikit lah. So I hope you guys understand. Okay, sorry, it's already 11:45. Macam mana Syuib?
Itulah dia punya menarik, dia punya perbuatan dia. Ataupun kita
topik sebenarnya. This is the last topic.
Okay, alright. Mungkin boleh apa kita panggil, speed tu mungkin kena laju sikit lah kot. Kita question saya put on hold at the end of session dululah.
Okay, but I try to, okay, again, we won't explain every single slide. I try to give you guys a summary. Boleh? I think it's much better lah. Slide ni you guys boleh baca, we can share it to you guys nanti. Okay. So topic number 4 is actually the bridge between NDT and the basic corrosion you guys tanya tadi. Okay, so soalan sebelum kita start, is any material invincible to corrosion? Ada tak? Ada tak any material yang invincible, dia tak akan corrode langsung? Okay, I assume
ada yang tanya copper
pun akan corrode, tapi
gold.
Okay, gold pun okay lah. I think okay. Tapi not suitable for our construction. Gold satu sebab mahal, satu lagi sebab strength dia rendah.
Non-metallic.
Okay, non-metallic pun yes, but dia ada another degradation which is UV.
Titanium.
Titanium pun ada juga dia punya corrosion dia.
Alamak, iPhone boleh corrode ke?
Okay. Kalau you letak dalam hydrogen lah. Okay. So nothing is truly invincible not even Superman. Kalau you tengok Superman pun dia ada apa? Kryptonite. So kalau ayat Batman tu, do you bleed? Yes, he bleeds lah kalau ada kryptonite. So not even Superman is truly invincible. So bila di mana ada kryptonite tu dia akan weaken. So similar to our metal, if you think that stainless steel is the answer for every problem, then actually we are wrong lah. Maybe it can be used for maybe like food industry and you ada less threats of surface ataupun atmosphere, but in oil and gas, stainless steel is not the ultimatum and it's expensive. Kalau you banyak duit pun tak semestinya solve the issue. Okay. So why? So there are several materials specific yang ada specific corrosion agent, such as stainless steel versus chloride tak boleh berkawan. Nickel alloys dengan hydrofluoric acid tak boleh berkawan. Titanium and hydrogen tak boleh berkawan. So your iPhone tu kalau you rendam kat dalam a very high hydrogen solution, dia boleh dapat titanium hydriding. So yes, titanium pun tak invincible. Okay, so again we try to categorize things based on the damage mechanism. Again, it's not for you to memorize, but for you to refer. You guys akan dapat the copy of the pack, no worries. So katalah you guys nak tahu what damage mechanism, giving you what mechanism, you boleh buka kat sini. Okay, and I also did some summary for you guys. Uniform corrosion, apa dia damage mechanism dia, localized apa dia, pitting apa dia, apa yang ada dua, uniform and localized, and apa yang ada localized and pitting. So I try to help you guys here lah. But most important, let's see how we want to detect the corrosion itself. So if let's say you have a general ataupun localized corrosion, so if let's say you can enter, you have an entry, accessible entry, visual is always the best. You boleh pergi tengok sendiri dengan your own eyes, and seeing is believing. And you can measure the wall loss using any gauges lah, like a pick gauge or a welding gauge yang boleh measure corrosion tu. But what happens if there is no entry? Kat sinilah kita pakai UT. So UT is, we call it a non-intrusive method. Why non-intrusive? Kita tak masukkan dia dari dalam, but we measure from outside. But we measure from outside to determine the corrosion inside, the condition inside condition dia. So let's say kat sini you jumpa localized corrosion. So dia akan bagi you indication kat situlah. Dia akan kirakan thickness yang lagi rendah kat sini. So again, UT scanning and thickness measurement if it's just a thinning mechanism. And you can also use profile RT. So profile RT ni you tembak daripada bahagian tepi and you want to measure the wall thickness. It is also used for corrosion and insulation. So if you see on the further right photo, there is actually insulation here. But why does the insulation does not appear on the image? You know that the insulation is less denser than the pipe. So that's why you can see there are an image of the pipe, and they can calculate the thickness lah, the thickness of this pipe. Okay, now we're on the cracking mechanisms. So I also helped you guys in identifying what damage mechanism is. API 571 giving you an intergranular morphology, and also what gives you a intergranular or transgranular morphology. Mostly is SCC lah, stress corrosion cracking. Okay, when you have cracking mechanism, what type of entity method that you want to use? So if let's say you can access, kita ada access to perform inspection. So let's say your product is this side, you kata you ada ammonia ke, you ada caustic ke yang akan menyebabkan cracking and embrittlement. So you perform inspection from inside of the vessel. So what you do, you can perform penetrant testing, ataupun you boleh pakai fluorescent penetrant testing and magnetic testing, or dalam code dia ada sebut WFMT, wet fluorescent magnetic testing. You can use this because it is a surface breaking defect. Okay, again, another way around, if let's say you cannot access the internal part of your equipment. So what you want to do, you can perform shear wave UT, and you boleh buat shear wave UT untuk tengok ada crack ke tidak, and you can perform radiographic testing. Okay, again, when it comes to cracking mechanism, kalau kita buka balik kat sini kan, you boleh nampak ni tau, SCC. Kebanyakan SCC ni akan berlaku dekat dia punya weldment. Kebanyakannya lah, I'm saying kebanyakannya, but not all. So when it comes to weldment, you will always refer back to your fabrication punya NDTs. You akan buat RT, you akan buat UT. Okay, some reference, help reference for you guys. Buka ASME PCC3, table C-1. It will give you a whole list of damage mechanisms and what type of NDT that you can perform to determine your to detect your mechanism. Again, it's very impossible for us to cater every single damage mechanism into ours. Tapi I'm giving you some guides. Buka ASME PCT3, table C1, and you will see a whole bunch of list of damage mechanism for you guys to refer to. And dia siap bagi lagi your defect jenis apa, metal loss ataupun cracking ataupun material degradation ataupun weld defects. When it comes to casting defects and weld defects, senang kata fabrication stage. Okay, I think we are towards the end. CML is actually the terminology being used in API 510, 570, 653 is how we want to monitor our defects. Katalah kita ada satu degradation, let's say kita jumpa crack, tapi kita tak boleh nak repair crack tu, tapi kita nak monitor. So we can put a sticker there, thickness location at that particular area, and we perform whatever NDT methods that is suitable to detect the crack lah. But the most common CML is being used in API is to detect your thickness measurement. So you put sticker here and you perform UT untuk dapatkan thickness. Why? Why you want to measure the thickness? Go back to topic number 1 tadi. Kita nak kira corrosion rate. And eventually after the kira corrosion rate, we want to determine dia punya remaining life lah. So that is the end goal, to have an assessment of remaining life. Nak bagi tahu orang this particular vessel, mana vessel saya tadi, this particular vessel boleh hidup berapa tahun lagi, and we have to plan for the next inspection interval. Okay, but just take note a little bit. Alright, tak ada sini. Just take note a little bit when you have a localized corrosion, the CML is very important for you to determine. Macam tadi kita cakap erosion corrosion, you ada elbow, you always focus on the extra DOS of that elbow. Janganlah main buat dia, and janganlah ambil dekat straight pipe you takkan jumpa the localized corrosion. And so kalau macam in terms of vessel, if let's say you have a liquid, you have fluid inside, you ada dual phase gas and liquid. If let's say you know the liquid part akan corrode lebih, so your thickness measurement must be at the liquid level. You jangan ambil tempat yang gas, sebab it won't represent the actual damage mechanism. Alright. I think we are towards the end. Let's just conclude a little bit the whole topic. Kita ada dua. Conclusion dia is many forms. Corrosion can appear in many forms with a specific morphology. It always depend on what is your product ataupun what corrodant yang akan intact with your metal and how it reacts and with the exposed environment. And the next conclusion is whatever editing methods that you want to apply, you have to be able to detect that expected damage mechanism lah. So no point you buat satu editing method, but actually the capability of that editing method is it cannot detect your crack ataupun you punya damage mechanism. Contoh, you nak check crack, tapi you pergi buat UT biasa, UT thickness, you cannot determine crack punya depth kat situ. Okay. Alright, I think we are at the Q&A session. Anyone want to ask?
Sangat menarik presentation tuan ni. Alright, okay. Kita ada selaju soalan yang pertama. Soalan pertama ditanya oleh Cik Omar, kenapa API 571 selalu digunakan instead of PCC3, Tuan Kus?
Okay, if I may answer that, dalam industri kita, industri kita tu bila I cakap pasal oil and gas, I lupa, we are in the industry kan. Industry oil and gas, API covers oil and gas, petrochemical refineries. ASME cover a bigger range sebab ASME is American Society of Mechanical Engineer, not just oil and gas, other industry as well can refer to ASME codes. Contoh kawan kita yang daripada food industry tadi, dia bukan oil and gas, tapi ASME is still applicable. So that's why in oil and gas, normally orang akan refer API 571. But in other industry, maybe they will refer more on the PCC3. Cuma kalau menjawab soalan tu lebih sikit, PCC3 is actually for RBI sebenarnya, bukan damage mechanism per se. Cuma ASME PCC3 also make reference to API 571. So in a way dia macam correlate with each other juga sebenarnya. Menjawab soalan ke?
Alright. Kita tunggu Cik Omar bagi respon. But in the meantime tu, Lanang sebut pasal API 571, ada dua orang tanya dekat Tuan Coach, boleh bagi tips sikit tak macam mana nak lepaskan pas API 571 punya ni?
Okay, bila orang sebut tips ni, I believe satu I would like to congratulate siapa yang tanya soalan tu. It means that that particular person atau tak tahu he or she is interested in taking 571. Just to give you guys some background sikit. Dalam banyak-banyak cert saya, when I started my career, I did not had any intention to take 571. Sebab I rasa macam satu, I am more on the inspection punya subdisiplin. So I cakap macam 571 ni lebih pada corrosion, buat apa yang nak ambil. And I know that 571 is a very hard examination to take, because it's very verbatim tau. Verbatim ni maksudnya soalan you tu memang bulat-bulat jawapan dia is from the code. So what you have to do, there's no shortcuts. You have to hafal lah. So okay lah, tapi the tips kan, bila you minta tips ni, again, kalau you perasan tadi, I try to categorize things. How I take my exams, sebenarnya if I may share some tips, not just for 571, for any API examination yang I take, I try to restructure my brain and not try to understand the whole code perspective. So apa yang saya buat, I try to restructure lah the code tu to suit the understanding in my brain lah. And so I try to categorize thinning mechanism, environmental cracking, high temperature, metallurgical degradation. Sebab when you try to separate those things, you jadi kurang overwhelmed sikit. So maksudnya kalau katalah you tanya soalan sulfidation, kan, I boleh cakap sulfidation tu high temp sebab ingat benda tu duduk dalam kategori sulfidation. Tapi if let's say you buka API 571 2020, you buka kategori ikut alphabet kan, you pun tak tahu dia ni cerita pasal apa. So you have to have a common understanding of the category dulu.
Alright, cantik. So kita wish luck lah kepada Cik Nazmi.
Ya, good luck Nazmi.
Alright, yang mengenai soalan pertama tadi tu, ya Cik Omar give a green light yang memang menjawab soalan lah. So I will go through ada question juga Tuan Kush. Mungkin in term of the CP question yang tadi tu, I put at the end. Saya fokus yang mana yang related on the training part dulu. Whereby the first question dia tanya in term of macam mana kita determine location of the CML. For example, kalau kita ada column inspection, adakah kita kena buat 100% inspection coverage for the overall column? Macam mana Tuan?
Alright. I didn't cover this in the pack, tapi let me explain it in terms of the industrial practice. Okay, by the way, thank you for the question. It's a very good question. It's a very advanced question sebenarnya. Okay, how to determine your location? Kalau you ada RBI and risk-based inspection, always refer back to your inspection reference plan. You ingat tak I tulis apa kat sini tadi? numbers of CML points usually depends on the inspection reference plan and usually depending on the expected damage mechanism. So bila you buat RBI, sebenarnya you dah buat corrosion study tau. You punya corrosion engineer ataupun you punya corrosion specialist dah determine siap-siap dah dalam vessel ni ataupun column ni ada what type of damage mechanism. And you know where the potential area that it will attack. So you know where the potential area attack, situlah you buat inspection. Kalau you tahu tempat yang dia less potential, kat situ you kurangkanlah buat inspection kat situ. You lebihkan tempat yang you memang expect to do it. Again, bila you buat inspection kan, it's not just you ambil satu barang ni you inspect 100%. That is actually a bad inspection practice. A good inspection framework ataupun a good inspection structure is actually where you determine the criticality of the damage mechanism and you want to tackle it focusedly lah. You nak fokus tackle benda tu. You tak nak lah buat semata-mata untuk buat checklist je. Okay, I dah inspect. Yes, you did inspect, but did you inspect it properly? Did you inspect it adequately and efficiently? Tu soalan. So a good inspection practice is always efficient lah. You buat apa yang you perlu buat. And you janganlah buat something yang you tak perlu buat pun. So how you determine? Again, you kena tengok dia punya type of mechanism tu apa. Uniform ke localized? Kalau uniform, you can just put a very low numbers of CML. Katalah this is a uniform corrosion, katalah dalam dia apa? Dalam dia air. So air, general corrosion, I boleh buat 1 atau 2 point dah cukup untuk represent the whole vessel. Tapi kalau benda ni is a very dual phase punya vessel, ada liquid, ada vapor. So you know that the vapor akan ada damage mechanism lain, bawah akan ada damage mechanism lain. So maybe you kena buat 2 portion of CML. So dan keliling mungkin you kena buat semua kan. So does that answer the question? Ke ada yang tertinggal?
Saya rasa jawapan tu pun macam actually covering what's the question intended lah Tuan Coach.
Okay.
Macam tu saya move to the next question. So Cik Amir had faced 2 type of term kalau regarding on RT. Satu is talking about 100% RT, satu lagi full RT. Ada beza kedua term ni Tuan Coach?
Okay. Quick answer, tak ada beza. Full RT and 100% RT is the same thing. But where do you use this full RT and 100% RT is actually during the fabrication stage. Sebab bila you ada full RT ataupun 100% RT is actually to determine the thickness required for your so-called vessel ataupun piping ataupun pressure part lah. Sebab again kalau kita nak go to very deep, T required dia ada formula dia dan dalam formula dia tu ada joint efficiency. So joint efficiency ni adalah dia nak bagi some credits to your joints, welding joints tu. So macam mana you nak bagi credit? Kalau you buat full RT, you ada 100% coverage. You kata, I dah buat 100% RT, 100% RT ni menunjukkan all the joints in that particular pressure equipment is inspected and free of defects. So maknanya kat situ you bagi joint efficiency yang paling tinggi lah. Tapi let's say you kata tak buat full RT, maybe you dapat 0.8 or 0.6. So dia akan kurangkan sikit your confidence kat situ dan your punya T required akan jadi lagi tinggi. Itu kalau menjawab in a very bigger context lah.
Baik. Jadi sementara kita tunggu feedback pada Cik Amil, mungkin saya bacakan soalan seterusnya dulu. So Cik Zarik tanyalah, jadi untuk heat exchanger tadi, kita ada limitation dekat band area. So apa practice, the best practice yang boleh kita buat inspection dekat band area? Sebab kita tahu that several test, tube test ni dia ada limited dekat band area tu Tuan Coach.
Betul. I've heard of this technique lah, tapi I sendiri tak pernah buat. Nama dia acoustic emission. Acoustic emission kata boleh cover the whole area termasuk band. Sebab how it works is it uses acoustic emission punya method. So it's little bit different. They propagate through the internal surface of your whole tube. But I know that the method itself is very, very, very sensitive. So kalau lah you kata ada air yang kata you ada lubang kan, you ada tube tapi berlubang dan lubang tu ditutup oleh air, your acoustic emission wave tak boleh baca sebenarnya. So in a way takut dia akan jadi some misinterpretation lah. But the coverage, yes, the coverage can cover the whole portion, but is it effective? It's a different question lah. Again, I'm not saying that inspection method is not correct, but actually the preparation, the implementation tu is very very sensitive. You kena be very very careful lah kalau nak implement benda tu. Besides that, itulah I dengar ada orang buat RT, profile RT. I'm not sure how efficient that is lah. But in terms of field inspection, no, we cannot cover that area. It's a very limitation lah.
Alright, baik tuan.
Yep.
On that, so I'm moving to the next question. So, Cik Kumar tanya, in terms of the RT, so the radioactive material yang kita guna kan, usually what kind of material kita guna yang easily to be maintained then can be easily stored lah.
Oh, you mean the RT source I think
Betul.
he refers to the RT source kan. Actually there are several types of RT source yang kita ada lah. Ada uranium, ada macam-macam lah. But the normal that we use, okay, before that dia ada dua types sebenarnya RT. Thank you Kumar, is it Kumar kan? Kumar for the question. This is actually covering on NDT methods sebenarnya. Tadi I tak cerita sebab it's going to be a little bit detailed. But RT source ni ada dua jenis sebenarnya. Satu is gamma ray, satu lagi X-ray. Gamma ray is using the natural source of gamma source yang kita jumpa daripada Earth punya radioactive source lah. But X-ray is a manipulated punya way which we can just switch on and switch off pakai electric lah. So when you have power supply, dia akan emit the radiographic punya wave, but when you switch off, dia akan close. So in terms of safety, X-ray is the most the safest source lah sebab you ada control in terms of switch on, switch off. So if whenever you use RT, whenever you use X-ray, it is highly recommended using X-ray lah sebab dia boleh switch on, switch off, and sensitivity dia lagi power. So that's why orang pipeline dia banyak suruh pakai X-ray. Okay, but when it comes to the natural source, gamma ray, kita ada the most famous is iridium, iridium 192, 192, and cobalt 60. Dua tu yang biasa kita pakai lah. But there are more than that sebenarnya. I cannot remember what type ataupun nama dia. Tapi the mostly used in the industry is those two lah. Tapi cobalt 60 pun tak silap saya dah tak pakai sangat dah sekarang. Kita banyak pakai iridium 192. Okay.
Alright, baik, thank you Tan on that. So I'm moving to the next question. So Cik Zahri tanyalah, so Cik Zahri nampak there are several reference stated dalam presentation Tuan Coach macam API 571, 581 and Atlas corrosion NACE PCC3. So what is else reference do you have or refer for damage mechanism or corrosion, and what kind methodology test commonly practiced industry associated with corrosion and damage mechanism?
Methodology test ke tadi tu?
In which inspection engineer should familiar with.
Okay. Susah nak jawab soalan tu. Which kalau you jadi inspection engineer, there's no good news. You kena familiar dengan semua. Familiar the keyword is familiar, bukan hafal. Sebab semua orang ingat kita hafal. Actually no, it's familiarize. So bila familiarize ni, you tahu the code ni cerita pasal apa, code ni cerita pasal apa, and kalau you nak cari jawapan, you know where to find it. And dia ibarat macam you nak cari kuih keria kan. So kuih keria you cari kat mana? Kat Melaka lah. Nasi kerabu you cari kat mana? Kat Kelantan. Macam tu lah lebih kurang. So becoming an inspection engineer is always becoming the reference point for people. Orang suka tanya soalan tu kat inspection punya team. Sebab I tak tahu lah kenapa kan, tapi in the industry dah design macam tu lah. Inspection dia kena tahu pasal code standards. But answering the question, damage mechanism is sufficiently kalau you buka API 571. Sebab API 571 gives you a very good guide in terms of how you want to manage corrosion ataupun any damage mechanism yang you ada lah. Not all, tapi I would say it's a very comprehensive punya document yang you boleh refer back as a guidance. So keep guidance bukan hafal, jangan hafal. You tak mampu nak hafal all 67. Memang tak mampu. Tapi bila you nak cari jawapan, you cari on the right place lah.
Alright, baik. Thanks for the advice. Kita ada another advice, Tuan Kush. So kita ada Miss Zulaika. Miss Zulaika, I guess is a fresh grad. So Miss Zulaika nak dapatkan advice pada Tuan Kush lah. Apakah tips untuk to be in the corrosion and inspection industry sebagai fresh grad lah? Apa dia kena priority dulu? Adakah obtaining cert ke ataupun actively apply corrosion punya job? Tuan Kush bagi advice untuk Cik Zulaika kita.
Sorry, saya terpaksa minum air sebelum nak jawab soalan ni.
Macam panjang tu. Kita
okay. To be honest, every time there is a webinar, every time there is I buat jadi speaker ke apa, this question memang akan keluar. I know everyone is looking for a job, everyone is looking for a career, but there is no any answer to answer that question. Should I take a cert dulu ataupun experience dulu, ataupun should I take experience dulu ataupun cert dulu kan? Sebab nothing can guarantee whatever rezeki yang you dapat lah. Memang bunyi klise, tapi it is actually rezeki Tuhan lah, benda satu yang it works for you lah kan. But if I may give an advice, duniawi punya advice, be familiar with all the terminologies. Always look ways for you to learn in terms of corrosion. Sekarang ni your source right now is very wide. You ada LinkedIn, you ada YouTube, you ada macam-macam source untuk you cari jawapan. And I think the most important part is being curious. And you being curious with the topic, and that curiosity will actually help you to build your knowledge and experience dan sebenarnya. And kalau you guys tengok Ted Lasso kan, Ted Lasso ada satu quote dia kata, be curious not judgmental. So actually the curiosity tu sebenarnya bagus untuk you tau. You jangan ambil a certain topic at the surface level, you terima macam tu je. Be curious. Sebab tu I suka you guys tanya soalan. It is a very great way for you to gauge your understanding, to get more knowledge, to get the logical reason of that particular topic atau subject lah kan. But in terms of fresh graduates, sorry, we don't really have an answer for that. But again, try to keep up with all the latest issues, plant issues. And kalau you tengok sekarang ni banyak isu-isu pasal hydrogen induced cracking, apa lagi, HTHA, hydrogen high temperature hydrogen attack. I think lately pun sulfidation is actually quite a good a very famous punya topic. If let's say you guys are familiar with that, and bila you pergi interview and you can talk about that, walaupun you budak fresh grad, I think your interviewer akan be amazed. Sebab not everyone can talk about it. Even orang yang dalam industri pun tak ada jawab benda-benda macam tu kan. But if you can prove yourself, you can give an impression to your interviewers that you know that, even though you are still work in progress, then that's a good way lah. Tu je lah yang saya boleh cakap.
Alright, thank you Tuan Kush for the advice. So I guess will be the last question yang akan cover for this session. And for others too, I really encourage you guys to keep contact with Tuan Kush through LinkedIn and also other platform that you can guys always seeking advice, right? So I go for the last question from Mr. Richard. So untuk small bore piping, particularly on carbon steel, it has been known to pose a significant challenge due to the wall thickness. So may I know the method used for SBP inspection, or the solution will resort to CRA material for SBP, Tuan Kush?
Okay, thank you for the question, Richard. I believe there are two things you want to ask there. Satu on the SBP part, and satu lagi pasal CRA. So when you talk about CRA, I believe it's not carbon steel. CRA is corrosion resistant alloy. So mostly all the alloys besides of carbon steel is referring to CRA lah. But what I can say for generally for SBP, small bore pipings, how you want to tackle small bore pipings is quite different than the normal big bore pipings, sebab you can perform UT based on the flow direction and whatnot. But when you talk about small bore piping, especially those inside insulations, and so you akan ada threads in terms of CUI, you akan ada thread in terms of dead legs. So dead legs is a part of API 570 punya coverage for small bore piping as well. So if I can remember properly, dalam API 570 sekarang, the latest one 2024 ada mention about diameter of piping. If let's say is 1 inch and below, you dah tak boleh buat UT. But more than 1 inch, you can still perform UT. But here's the catch. What type of UT you boleh buat? You kena pastikan your UT probe is very small. Dia punya diameter probe tu tak silap I 5mm. Yes, 5mm. The 10mm probe tu tak boleh buat because when you have let's say pipe okay. Bayangkan this is your probe, this is your pipe. If it's very small, you tak akan touch properly tau dekat you punya pipe material. So you akan ada rocking ataupun your coverage surface tu tak penuh dekat you punya curvature sebab curvature dia kecil kan. So you have to use a very small probe which is 5mm diameter probe to tackle 1 inch up to 3 inch. Tapi below 1 inch tak boleh buat lah, you kena buat profile RT lah. So that's the way to perform inspection, if I may give you an advice.
Alright, cantik. Baik. Alamak, saya terstop. Instead of screen sharing, saya terstop video Tuan Coach. Sorry for that. Alright, so okay, so I share my screen. So first of all, I would like to thanks to Tuan Coach for your sharing session. Daripada 2 jam kita dah ke 3 jam, which mean itu pun masih tak cukup masa lagi, which mean the topic that you share is really interesting. Even me as a process background pun actually I also quite interested with this topic. It's not just operate the plant, tapi I need to know all of this as well lah. Alright, so to participant, first of all we would like to thanks for your time, and also we are sorry for the time extension, but I guess you got the benefited from the time extension, and we would like to encourage you guys to follow Tuan Kush dekat LinkedIn. So Tuan Kush punya LinkedIn as share in the screen, ni nama Tuan Kush punya LinkedIn lah. And also I also encourage you guys to follow Engineer Digest and myself, and also Tuan Syed Idrus in LinkedIn as well. So for any question yang saya tak dapat to attend, we would like to say sorry to you guys, and for others, yes, please if you have any question ke apa afterward, boleh tanya Tuan Kush terus lah through the LinkedIn apa. Jadi Tuan Kush ada buka, ada share apa panggil, ada share something in the chat box. Please open juga benda tu, okay? And maybe Tuan Kush would like to say last word before we end.
Okay, thank you Shuib for the last words. First and foremost, thank you very much Engineer Digest for the invitation. Again, bila Syed Idrus approach me earlier, I think back in July kot dia approach me. So dia kata boleh tak buat sharing. Yes, I said boleh sebab I do believe that I really believe in continuous learning sebenarnya, and I believe that in sharing knowledge is the thing that we have to cultivate lah, dia benda culture tu. So this is a platform for us to share knowledge, bukan mengajar especially share knowledge, share experience for the betterment of the industry lah. And so again, I encourage you guys, bukan encourage lah, let's connect in LinkedIn. You ada soalan apa, I know these 2 hours is very cramped and takkan cukup masa untuk menjawab segala soalan, segala curiosity inside you guys, but let's connect, and you can always contact me through LinkedIn if you want my perspective of it lah. Okay.
Right, for sure. Maybe we can have ada topik juga afterward by Tuan Kush.
Boleh.
InsyaAllah. Baik, so for participant, what afterward, so dalam masa seminggu, we will provide to you on your certification and the training material yang just presented by Tuan Kush, slide yang cantik, dan juga the training recording, all of this we will provide to you within 1 week lah. So I guess that's all for
Kita boleh ambil gambar tak? Syed, boleh ambil gambar tak last?
Yes, for sure. Kalau macam tu,
Gambar satu.
saya
Atau mana nak
encourage
semua orang.
saya encourage semua orang, jom kita open your video just for a while saja. Boleh. Kita
Sebenarnya je ambil gambar jap.
boleh jom.
Kenangan. Ke dia orang tak ada akses untuk buka kamera?
Ada. Semua dah diberi. Jom semua kita buka gambar sekejap.
I am here.
Maksudnya kan?
Dia tu.
Malu. Sorry ya, ada gangguan.
Alexa.
Awak ni kursi urut.
Oh, Jintel.
Betul. Lupa dah tutup dia.
Patut macam familiar bunyi tu. I am here.
Oh.
Tapi very random kan dia punya.
Tak
Tak ada orang buka video.
Tak ada orang. Wah, semua malu-malu ni.
Tak apalah, it's okay lah.
Okay, alright. Sekadar macam ni pun okay dah kot?
Okay.
Okay, done. Alah Cik Amirul, lu nak buka.
Alhamdulillah, dia baru buka dah hilang dah.
Alright, kalau macam tu tak apalah. Alright, so I give dalam seminit 2 before I close this recording and also